A very good morning and welcome to the OCTAVE Advanced Analytics Symposium organized by OCTAVE, the John Keells Group Data and Advanced Analytics Center of Excellence, and the cornerstone of the group's data-driven decision-making. My name is Chamodi Adhikaram. I'm a data scientist at OCTAVE attached with the retail sector, and I will be the moderator for this symposium. OCTAVE, John Keells Group Data and Advanced Analytics Center of Excellence, leverages its distinct position as a thought leader in the industry to collaborate with universities on competitions and knowledge sharing sessions with an aim to pioneering curiosity in data among the innovative youth. The OCTAVE Advanced Analytics Symposium provides a virtual platform for final year university students to present and share their findings of their theses and research projects related to data and advanced analytics with a wider audience of data enthusiasts and industry professionals. Once again, I warmly welcome you all to the first ever OCTAVE Advanced Analytics Symposium, and thank you for attending today to observe the 16 finalists compete. I would like to make a couple of announcements before we commence. First of all, let us move on to the agenda of the symposium. We will begin with 9 thesis presentations by the finalists. The first presentation is titled as Statistical Machine Learning for Medicinal Plant Levers Classification by Jaini Lakshika from Bachelor of Statistics in University of Sri Jayawardhanapura is scheduled at 9:15. The second presentation, Modeling and Short-Term Forecasting Floods in Ratnapura area due to Kaluganga using novel machine learning techniques by the team Analysta. The team members are Sandalu Jayasooriya, Vimukthi Algama, and Krishan Madhusanka from Bachelor of Science in Electrical and Electronic Engineering, University of Peradeniya, is scheduled at 9:35. Automatic modulation classification using machine learning techniques by team classifiers. The team members are Nirmal Vikramasinghe, Shehan Steinwall, and Isuri Valgama, Bachelor of Science in Electrical and Electronic Engineering, University of Peradeniya, is scheduled at 9:55. The impact of socio-economic characteristics of shoppers on retail store choice decision results from multinomial logistic regression modeling in Sri Lanka by Vithanage Shashikala from Bachelor of Science in Town and Country Planning degree, University of Moratuwa, is scheduled at 10:15. Objectively measuring player performance in Olympic weightlifting by Team UOP Elites, Chamin Jayasooriya and Anandi Karunaratne are the team members. They are from Bachelor of Science in Computer Science degree, University of Peradeniya, and the presentation is scheduled at 10:35. Vehicle tracking based on an improved deep sort algorithm and the YOLO V4 framework under different lighting conditions and inter-vehicle distance estimation using neural network regression by Team Metrics. The team members are Shihan Seneviratne, Imali Pereira, Aseni Jayaratne from Bachelor of Science in Electrical and Electronic Engineering degree, University of Peradeniya, is scheduled at 10:55. Determining the invoicing dates for raw materials, order and finished product dispatch using neural networks and the exchange rate volatility by Janit Veerasinghe from Bachelor of Science in Transport and Logistics Management, University of Moratuwa, is scheduled at 11:15. Recalibrating retail store inventory and service levels considering the presence of credit card promotions by Randula Jayasinghe, Bachelor of Science in Transports and Logistics Management, University of Moratuwa, is scheduled at 11:35. Blending behavioral factors and task sequencing for efficient warehouse operations by Kasuni Veerasinghe, Bachelor of Science in Transport and Logistics Management degree, University of Moratuwa, is scheduled at 11:55. At 11:15, we'll go for a break, allowing some time for the judges to tally their marks and select the winners. And we'll be back sharp at 12:45 to announce the winners. And the symposium will be concluded at 12:50 with a vote of thanks by Dr. Karunaratne, the principal data scientist at OCTAVE. So let me introduce our judge panel. We have an interesting panel of judges from OCTAVE joining with us today. First of all, let me introduce Lamana Mulafar. She's currently working as a senior data scientist in the retail stream. She earned her bachelor's in computer science from Carnegie Mellon University, USA. And her areas of expertise are in AI in healthcare, AI in retail, and natural language processing. We also have Arun Thevapalan, who's currently working as a senior data scientist in the retail stream. He earned his master's degree from University of West London, and his areas of expertise are data privacy and computer vision. We have Ishika Karunaratne joining as a judge today, who's currently working as a data scientist in the beverages stream. He earned his Master of Science degree from University of Moratuwa, and his areas of expertise are machine learning and natural language processing. We also have Ruwan Sri Vikramaratne, who's currently working as a data scientist in the retail stream. He earned his bachelor's from University of Colombo, and his areas of expertise are machine learning and statistics. Now, let me outline the rules and guidelines of the OCTAVE Advanced Analytics Symposium. The duration of each presentation will be 12 minutes. At the 11th minute, I will announce 1 minute left so that the presenters can wrap up their presentations. And the presentation must end within 1 minute after this announcement. This will be followed by 3 minutes Q&A session with the judge panel. And the presenters must ensure that they turn on their cameras while presenting and share their presentation off from their screens. Like I mentioned earlier, the winners will be announced at 12:45. So please make sure that you are present at that time. So that's about it. Those are the announcements that I had to make. So without further ado, let's start the symposium. And I would like to remind the spectators to mute yourselves and turn off your cameras so that the presenters will not be disturbed. We have our first thesis presentation for the day. This is titled as Statistical Machine Learning for Medicinal Plant Leaves Classification by Jayasooriya. She's from Bachelor of Science in Statistics, University of Sri Jayawardhanapura. In this research, she introduces a novel approach to detect leaves with medicinal value, aptly named MEDIP, which is short for medicinal plant identification. Jaini, could you please turn on your camera and state your name for an audio-visual check?
Yeah, I'm Jaini. Can you hear me?
Yes. Awesome. Okay. Could you please share your screen with the presentation as well?
Yeah, right.
Great. Okay, we can see your screen. Okay, Jaini, you may begin now. Good luck.
Thank you so much. Good morning, everyone. I'm Jaini Lakshika from University of Sri Jayawardhanapura, and I'm currently working as an associate data analyst in Visualmatics. And I want to thank you, OCTAVE team, for giving me this opportunity, as well as my supervisor is Dr. Tiyanga Talagala, one of the senior lecturer in University of Sri Jayawardhanapura. Statistical machine learning for medicinal plant leaves classification. I think, did you guys notice about this post? This is a post that is published on social medias like almost 1 year ago. This is a prescription for ancient herbal drink has been shared thousands of times on Facebook and WhatsApp alongside a claim that it is an effective remedy for novel coronavirus, COVID-19. And the medicine contained 11 varieties of medicinal herbs, which it states should be boiled together and consumed daily. Before going on to my presentation, I want to give a small introduction and background knowledge about my topic. I think you can see these two graphs. First of all, I will move on to the first graph that was in the left side. You can see that in the left side of this graph, this contain the distribution of medicinal plants in the countries, and this is the top 15 countries that has the medicinal plants. These are the statistics that I generated from the WHO statistics, and you can see that Sri Lanka is in the top 15 positions. And also China, India, and USA are the top positions in the graph. Is it logical to think about only about the medicinal plants? We have to compare the number of medicinal plants when compared with the total number of plants. The second graph shows that as a percentage of the total number of medicinal plants, you can see that Sri Lanka has a high number of medicinal plants. As also, you can see that in the first graph, you saw China was in the top when compare only the medicinal plants. But when comparing the total number of plants, you can see that China was little bit lower position. As I mentioned earlier, Sri Lanka is rich from medicinal plants. Therefore, world famous countries has eye on the medicinal plants and Ayurvedic treatments in Sri Lanka. This is a proof of that. You can see these are the statistics I generated from the trade statistics, and you can see that China, India, USA are the top countries that Sri Lanka export the medicinal plants to China, Hong Kong, USA, like the world famous countries. With the high usage of medicinal plants, people interested to grow medicinal plants in their gardens and know how to identify them. This is a little famous topic in these days. Usually, medicinal plants are identified based on years of experience through sensory or olfactory senses by practitioners. Laboratory-based testing is another method that is costly, time-consuming, and require expert knowledge. But think a little bit. What to do the people who haven't experience about the herbal recognition? There is no standard mechanism is introduced yet for this herbal recognition, but through my research, I will introduce automatic way to identify medicinal plants. Main objective of my research is to develop an automatic algorithm to classify medicinal plants using medicinal plant leaves. Medicinal plant leaves. Why medicinal plant leaves? If we take plants, we can have flowers, roots, and there are another components in the plants. But most of the researchers has their concern in medicinal plants leaves. The reason is leaf images contain a large number of diverse set of features like shape, veins, and edge features. These features can be used to identify medicinal plants. Another advantage is the leaves easy to obtain without damaging the plant. It is also important because there are endangered plants, and in these days medicinal plants are really important. Therefore, we have to preserve them. Therefore, we must take care of without damaging the plants. This is my first package. I was published as an open source R software called Medley, and it is publicly available in my GitHub repository. And we got the grant submissions lately. And this package contains morphological and structural features. There are 21 features, and 4 of them are like the ID and the local name, family names, and some descriptional things. And there are 18 number of feature description as well. And there are 471 medicinal plant leaves. And also I collected by myself, I collected 1099 leaf images of 31 species. I that was a challenging task for me due to the COVID-19 pandemic, but finally I did it. And this is the small screenshot of my data set. You can see that contain the shape, arrangement, and edge types of the leaf features that I have to do more researches, because this is a new topic for me. And I did some researches and identify what are the edge type shapes and arrangements of the leaves, and finally completed the data set and published it into the CRAN. And if I consider the methodology of my research, this is the overview of my research. You can see that if I begin from the left side, this is my image data sets. The Flavia, Swedish, and Kegel data sets are Kegel and UCI data sets are the secondary data set, and the actual data set is medley that is collected by myself. And by using these repositories, I I divided the train and test sets, and I do the image processing. And I had to work on these things in most of the time, identify, because there are the types of the data sets are really different. Therefore, I have to identify the patterns of these images, and also as the next step, I do the feature extraction. And as a new to my thesis, I introduce, rather than in the normal features in the leaves, I introduce some new features like correlations of Cartesian contour, and the center x and y values of the center, maximum number of maximum points, minimum points, convex points, and scagnostics of the Cartesian and polar coordinates. And this is the overview of my research. Let's move on. As the first step, I did the image acquisition. In the medley, publishing of medley, I had collected the images by myself. Therefore, I had to identify what are the best steps I had to follow to get the take the photos of the leaves. And I identified that this is the best procedure we have to go through. We have to first pick the leaf from the medicinal plants without damaging the plant. Then I have to clean the leaf by using a brush or small paper. And I have to press the leaf maybe in some time, and it is changing according to the time period, and put the leaf in the center of the white paper. I am using a white paper because I want to get the homogeneous background, because if I have a heterogeneous background, I have to do another processing, and it will be my next step of my research. And I have to take the closest image without flashing as well. And it is because I have to remove the noises of the light illumination. And you can see that this is a small map I created, and Flavia dataset from China, and my medley dataset in Sri Lanka, Swedish dataset from Sweden, and Kegel dataset which contain binary images from UK. You can see that for my research, I used the different data set from all over the countries, and I want to generalize it. As image processing step, I go through convert to RGB values, grayscaling, Gaussian smoothing to remove noises, and binary thresholding, and resize all the images. Rather than in the main steps, I also follow closing holes of the leaves, because they can be damaged leaves sometimes, and also for the algorithm purposes, I remove the stock as well. And this is the another most important and challenging part: features. In identification of plant species using leaf images, features of leaves play a main role. In previous researchers, they let the algorithm to train and like CNN to extract features by itself and do the classification. But it's like a black box, and I want to see inside the black box and see whether what is happening inside that. Therefore,
You have 1 minute remaining.
it is so hard to interpret and generalize the features, and I introduced 52 features in there, and these are the small features that I generated from my research. And also I want to show my visualization. Is my features are is enough to classify the leaf images. I present it by PCA and LDA. You can see that as a first step of the hierarchy, my leaf images are classified well. And if I talked about the algorithm development, Medipai my algorithm development package will be published soon. In the training and testing process, visualize that. As a discussion, according to my hierarchy, these are my shapes and the arrangement of the features, and these are the H types of the features, and the hierarchy that I.
Yes. Thank you. Your time is up, unfortunately. It was an interesting presentation indeed. Yeah. Judges, do you have any questions for Jayani?
Yeah, I've got some questions for Jayani. So thanks so much, Jayani. Very, very interesting presentation. I've got a couple of questions. So one is it enough to accurately, are you aware of whether it's enough to accurately decide if a plant is A, B, or C based on just their leaves alone?
Yes, I proved that. Can I show some slide for you? Yeah. Beyond to my research, according to my research, I followed a hierarchical and non-hierarchical process. And according to the statistic that the models and algorithms that I followed, and using, you can see that these statistics, and you can see that the accuracies that according to my research, I use the hierarchical procedure, and you can see that random forest of the hierarchical procedure give the best results among the all of them. And
okay.
Yeah.
And what is the sample size for this one? You mentioned 31 what is the size of the data set? You mentioned 31
1,099.
1,099. But how many different types of leaves?
31.
31 different types of leaves. 31 different species. Okay.
Yeah.
So roughly then each species getting like how many?
25. Yeah.
About 25. Okay.
Yeah.
Okay. And did you notice that you mentioned that you had like data sets from different parts of the world, right?
Yeah.
Did you notice that the same species might have different types of leaves across, different geographies? Was that a thing?
Yeah. I want to show you something in here. There. Can I share it? Yeah.
Jayani, are you going to share the screen?
Yeah. I'm sorry. Yeah. I hope you can see the plot. Yeah. This is the plots that I created from the datasets, because I mentioned that my Medley, Flavia, and Swedish datasets are containing only the color images. Then I want to see that these datasets are in the because they are in the different countries, and see whether is it really different. And I use LDA to visualize that. You can see that by generating all the features of the all the 3 data sets and visualize these things in LDA, you can see that these 3 data sets are in the different positions and they are not merged together.
Okay, thank you.
Yeah. Thank you.
Okay, thank you, judges. This marks the end of the Q&A session. Thank you, Jani, for your interesting presentation.
Thank you so much.
I think applying a novel area like machine learning in a domain like indigenous medicine is the true beauty of AI. You know, it's the ability to bring together different science and technologies. So it was an interesting presentation. Before we move on to the next presentation, judges, I would like to remind you to record the marks. Okay, so the next presentation is titled as Modeling and Short-Term Forecasting Floods in Ratnapura area due to Kaluganga using novel machine learning techniques by Team Analysta. The team members are Sandulu Jayasooriya, Vimukti Algama, and Krishan Madhusanka from Bachelor of Science in Electrical and Electronic Engineering, University of Peradeniya. What's interesting about this research is that the team has employed a variety of techniques such as regression analysis, time series modeling, and even neural networks to predict and forecast the water levels in Kaluganga in Ratnapura to forecast the flood events. So Sadhanu, Vimukti and Madhusanka, I believe all 3 of you will be presenting. So if you could please turn on your cameras and state your names one after the other for audio visual check. Please state your name as well. You can check the audio.
I'm Vimukti Algama. Can you hear me?
Yes, very good.
Okay.
And Sandalu, if you could go next. Okay, great. Next we have Madhusanka.
I'm Krishan Madhusanka.
Okay, awesome. So, so please share your screen with the presentation. Okay, great. So before we begin, let me again remind you of the rules. The duration of each presentation will be 12 minutes. At the 11th minute, I will give you all a reminder. And the presentation must wrap up within 1 minute after the announcement, and this will be followed by a 3-minute question and answer session with the panel of judges. Okay, all good. You may begin now, and good luck to you.
Thank you. Shall I start now?
Yes, you can start.
Okay. Good morning, everyone. I am Vimukti Algama, and my fellow partners are Krishan Madhusanka and Sandulu Jayasooriya, as mentioned before. So we are here to present our project, modeling and short-term forecasting of flooding of Kaluganga in Ratnapura area using novel machine learning techniques. So in this analysis, we try to make different models to predict the events beforehand and compare their performances. When we were doing the background search, we came across with different factors and factors that affect the floods. But according to this situation, among the factors we had selected, the overflowing water levels of the rivers were selected according to the data sets we have. So Krishan will continue the presentation from this point onwards. Krishan, over to you.
Thank you. This is also from the database we found from the disaster management website, which is useful for classifications. As mentioned earlier, the 2 datasets we have based on the river water level. The first dataset is the water level of the Kaluganga, and the second dataset is consists of few sub-rivers as well. To consider in the dataset 1, it has a reading of few every hours in Kaluganga start from January 2020. As first step, we look at the autocorrelation of the data set because we were planning to make model using the lag of revived set. So, as in the figure shows, the data is correlated to a very good extent considering the lags. Then we made a linear regression model using 100 lags. Here, we have used the least name square method to create the model. So here, we can see performance of the model. It is actually doing a pretty good job following the original curves. The box plot is shown here. Then we shifted the 100 lakhs backward hour by hour. As accepted, the error start to increase. The box plots are drawn to first few lakhs as shown here. As you can see, the variance increased with the time shifted. So then we can look at the model parameters for these shifts. The most important observation was that only the first few lags have major impact. So to simplify the model and to find optimal number of lags, we use AIC. Next, we start working on Arima model. Considering the Arima model is consists of autoregression, moving average, and integration segment. So, as you can see in the slides, autoregression is for long-term forecasting. Moving average is for short-term forecasting. And the integration part is for the compensation of stochastic trends. So to optimize the parameters, as we mentioned in previous case, AIC criterion is used in the Arima model, which actually help to optimize the number of parameters used by keeping the error is a considerable range. Here is the AIC formula confirm what we manually checked in the previous case, which only first few lags will be enough to make a good enough prediction. So the Arima 212 model was used. Here we can see the performance of the Arima model. The magnified plot is also shown in slide. The root mean square is around 4.48 centimeters, and the box plot shows still variance is pretty high. From this point onwards, Vimukti will continue the presentation.
Then what we did was we reassembled, we resampled the data we have as shown in the table. Previously, we were predicting 1 point ahead. Now, after resampling, as an example, if we sample if the sample interval is 2, that means we are predicting 2 points ahead. Likewise, we resample the data set until we can predict 5 hours ahead. We stop there because if we go past that limit, the error will start to increase beyond the considerable margin. So we can see how the root mean square increases, the root mean square error increases when sampling interval is increased, as the box plot shows. Variance remain in a quite similar way. Then we could find another data set which includes the water levels of sub-rivers as well. Those sub-rivers connect with Kaluganga near Ratnapura area, near Ratnapura town. A sample of the data set is shown in the table. And this is the website that we extracted data for this section. This is rivernet.lk, and the website is maintained by the irrigation department. This is how the sub-rivers are connecting to Kaluganga near Ratnapura area. Those sub-rivers have different kinds of effects to the Ratnapura water level, and these things will be discussed in the upcoming slides. in this case, we try to make a linear regression model first and check the performance. To do so, we wanted to know when the Kaluganga lags and the other rivers are most correlated points. So to find that, we plotted the autocorrelation and cross-correlation plots to confirm that. So here the lags up to 100 minutes are correlated for a good extent. And these are the cross-correlation plots of the two sub-rivers, Denamaka and Veganga, with Kaluganga. Likewise, we plotted all the cross-correlation sequences found and the corresponding lags. The summary of the cross-correlation given here with their corresponding lags, and it is also shown in the graph as well. So then by using above data, we made a linear regression model in the matrix H. The columns are assembled considering their correlation. The first column represents the hour lag, 1 hour lag, and the other columns represent the sub-rivers as mentioned in the previous slides. So here also the least mean square method is used. By using the above method, we wanted to we made two models to predict 1 hour and 2 hours ahead. The model weights corresponds to the 1 hour lag, and sub-rivers are shown here with their comparison. And this shows the performance of the two models. The error has increased in the second plot, which shows 2 hours ahead prediction. And these are the error values of the two models and the blocks plots. It can be seen that the number of outliers is still high. So this point onwards, I would like to invite Sandalu to continue the presentation.
So far, we considered only linear models. So we need to tackle non-linearities as well. So we develop a shallow neural network. Here, we develop a neural network with 3 hidden layers. We use a relative activation function as in hidden layers and RMS prop algorithm for optimization. And data is split 60% training, 20% validation, and 20% test. Next slide. So this shallow neural network is first trained with data of sub-rivers as input variables and predicted the water level of Kaluganga 60 minutes ahead. As you can see from the learning curve, although we train the neural network for 500 epochs, we could have reduced that for 100 or even less, because it converged before 500. And from the other plot, you can see the overall prediction for entire dataset. Here you can see how our neural network predicted the test data. We obtained group mean square of 0.0856 meters. Next slide. Now you can see the block spot for error for test dataset and entire dataset. As you can see, there's no difference in error.
Team, you have 1 minute left.
Okay, next slide. Here, next, what we did was we used same neural network and train it using the dataset which was used previously for linear regression model, and predicted the water level of Kaluganga 60 minutes ahead. As you can see from the overall prediction, now it is pretty good in peaks as well. Previously, at peaks, you can see some large error. Next slide. This is the performance for test dataset. As you can see, root mean square error is now as low as 0.0283 meters. That means 2.83 centimeters.
Okay, thank you, team analyst. I'm sorry to interrupt, but unfortunately the time is up. To some interesting results that you're presenting, but unfortunately we'll have to go for the questions. So judges, do you have any questions for team analyst?
Yeah, I have a couple of questions. The first one is like, how many data points did you have in your data sets and how did you divide it into the train and test data? What was the approach?
Yeah, for first model, for first model, there was a data set of entirely 1 year previously, not for me neural network model. For neural network model and which means section 2, for multivariable analysis, we use data of 9 days. Here, data is from data time interval is 1 week. In previous occasion, in section 1, data of 1 year from time period, time gap is, time interval is 1 hour. So that's the case. And
how did you divide it into train
previous?
In the linear, actually in the linear regression model, the data set we had was, as I mentioned, from 1 hour to 1 hour, and we had total points around 9,000, and we take around 80% to train the linear regression model, and we trained the model and we looked at the performances, and then in the neural network, we split the data set into 3, as mentioned before, 0.6% to train the model and 0.2 for validation and 0.2 for testing. Is it clear?
Yeah, yeah, and like any other external data sets that you use other than the water levels of these figures, like weather or anything?
Actually, this data set was given to us by Irrigation Department of Sri Lanka. This data set was given by Irrigation Department, and second data set was web scraped by also website which update 1 minute at a time.
And
so we
also the second data set we get was actually a new model that they have implemented that was created in January this year, and they have installed only the water level sensors at this point, and maybe we are also doing some research to install some rainfall sensors as well, so that we can check the correlations between the rainfalls as well with the water levels, and use everything to predict the water level at Ratnapura to predict the floods.
Okay. And like, have you considered the time gap that the authorities needs to action if, like, when you predict like there's going to be a flood? Did you consider that the time the authorities need to action on your prediction, like let's say they need at least 2 hours, 3 hours before the actual flood happens? Have you considered that when you do your prediction time horizons, or like you just did it to reduce the error?
In the previous occasions, there was a time that the water level was normal when at 7 a.m. in the morning, and a major flood has occurred around 1 p.m. So the time gap is around 6 hours, and that is the one of the most the trend of that event was the one of the most dangerous flood events that Ratnapura had in the past. And because it took around 6 hours, we considered 5 hours in this study, and we are trying to predict 5 hours ahead.
Actually, it was done in resample model. Here we did for 1 hour to compare and compare between the models. In this slide comparison of models, we done it for 1 hour.
Oh,
Okay, thank you, judges. This marks the end of the Q&A session. Thank you, team analyst, for your presentation. And if I'm not mistaken, it was in 2003 that we experienced the worst floods in this area, which unfortunately took about 200 lives. I think this is a great solution to an age-old problem that takes place, I think, annually in the district. And most importantly, a solution that will possibly save lives. So nice work, team. I think we can move on to the next presentation, but before I do, I would like to remind the judges to enter their marks in the mark sheets that's provided. Okay, and so let's move on to the next presentation, which is on automatic modulation classification using machine learning techniques by team classifiers. The team members are Nirmal Vikramasinghe, Shehan Steinwall, and Isuri Valgama. They are from the degree of Bachelor of Science in Electrical and Electronic Engineering, University of Peradeniya. This research is in the telecommunication domain, and the team introduces using machine learning in automatic modulation classification, a technique which is used in both military and civilian applications. So Nirmal, Shehan, and Isuri, could you please turn on your cameras and state your names for an audio-visual check? So maybe we can start with Nirmal.
Yeah, I'm Nirmal.
Hi, I'm Shehan.
Isuri?
Hello, I'm Isuri.
Okay, great. Okay, could one of you please share the screen with the presentation? Awesome. Thank you. Okay, let me once again remind the rules. So the duration of each presentation is 12 minutes, and I will remind you at the 11th minute so that it will help you to wrap up your presentations, and you must end within 1 minute after this announcement, and this will be followed by 3 minutes of Q&A session with the judge panel. Okay, so you may begin, team. Good luck.
Good morning, everyone. Here I'm going to present our project, which is automatic modulation classification using machine learning techniques. So this is my team. I am Shehan Steinwall, and my team members are Isuri Velgama and Nirmal Vikramasinghe. So as you can see in contents, we will discuss about the introduction and the system overview and the methodology and results. So in introduction, here, why do we need to identify the modulation type? So mainly there are two applications. First one is the military application, and the second is civil application. And in military application, there are three main applications. First one is electronic support. So that is to receive the transmitted message among the adversary units. And the second is electronic attack. That is to jam the communications between adversary units. And third is electronic protect. That is to protect inner communications from the adversary units. So in order to accomplish this, we need to know the exact frequency and the modulation type of the signal. So in the civil application, link adaptation is the main application. So in link adaptation, we need to keep a high link reliability and a high speed transmission. Therefore, we need to change the modulation type with the current situation. So at the receiving end, to get the original message, we have to demodulate the signal. So to demodulate the signal, we must know the modulation type of the signal. That's why we need to classify the modulation type. So in here, in modulation, what it does is it encodes several bits into symbols, which is dependent on amplitude, frequency, or phase. So at the when we transmitting that signal, we mix the encoded signal with the carrier frequency. So at the receiving end, when we receive the signal, we need to demodulate the signal. So to demodulate the signal, that's why we need the modulation scheme. So in the system overview second section, this is our model. So the transmitted signal comes through the channel to the receiver, and at the receiver, the noise will be added. So the signal is a time domain. So we have to convert it into the complex baseband domain. So to do that part, we will use the signal preprocessing unit. So then this is our signal model. So receiving signal is equals to transmitted signal plus additive white Gaussian noise. So as you can see in this constellation diagram, this is a complex plane diagram. So the complex baseband signal is plotted in this diagram. As you can see, we have choose 4 different modulation schemes. First one is BPSK, QPSK, QAM16, and QAM64. So this image is for a noise-free signal. So as you can see, when we decrease the signal to noise ratio from 30 to 20, 20 to 10, 10 to 5, and 5 to 0, the signal becomes more worse. The signal becomes distorted. So that's why we need the method to classify modulation type this case. In this case, so as the methods, we will discuss about few methods. First one is k nearest neighbor, and the second support vector machine, and the third decision tree classifier, and the data distribution analysis and deep learning approach. So in KNN, we have choose high order cumulants as the features. So what happened is, first we keep here some amount of data in different classes. Then we input the unknown data. Then we calculate all the distances from the unknown point to all known points. Then what we do is we rearrange all the distances values in the ascending order. Then we take the first kth number of data of distances, and then we vote on the labels. So the highest vote will be the predicted output. So in here, in KNN, dimension reduction is very important. So therefore, we have analyzed our data. Then we have chose 3 cumulant values as the features. So in support vector machine, as you can see in this figure, we need to separate the data into classes. So therefore, in SVM, we need to define a plane that can separate the data into classes. So this plane is known as the hyperplane. So when the known point is given, we substitute it to the hyperplane and we check the sign of the results. If the result is plus, which means positive, then the decision will be M1. If the result is negative, then the decision will be M2. So here also we have used high order cumulants as the feature. So comparing with the existing methods, as you can see here, in the red line is the SVM results that we have obtained, and this blue line is the maximum likelihood. That is a traditional statistical method, and GPKN, which we have obtained from the mentioned research paper, and GP stands for genetic programming, and this is our results which we have obtained from using a KNN with 3-dimensional vector. As you can see, still it gives a high accuracy result. So from here on, Nirmal will discuss about the other methods.
Thank you, Shehan. As Shehan introduced about high order statics as cumulant, we can use cumulant that is special probability parameter. We can call it as C40 and C42 that has the highest variability for our digital model in classification. Then we can use them to design our decision tree. Then this is a binary decision tree. We can decrease the data manually. That is, when we input random signal, this may not give optimum output. Therefore, we have to optimize our decision tree by special probability parameter we call impurity index. We can use our optimize our decision tree. Let's consider this scatter plot diagram. There is horizontal and vertical probabilities. According to the horizontal probability axis, we can define optimum vertical decision bound, as well as according to the vertical probability axis, we can define optimum horizontal decision boundary with respect to this mean measurement. Then after this classification, result of conclusion matrix according to this picture, we can see PAM modulation schemes and as well as QOM we can classify in 100% accuracy, but for PSK, high order PSK, we can't classify for in 100% accuracy because of this. For high order PSK with noise, the constellation diagram is converged to as a range set. Therefore, we can't exactly define distance boundary. Then, according to this binary distance tree classification, the other one is computationally expensive. Let's consider this circular and triangular data set. Obviously, these data two clusters we can classify in as a diagonal distance boundary, but in our case, this is binary distance tree classification. Therefore, we have to use vertical and horizontal decision boundaries. Therefore, our decision boundary is like a staircase manner. That is because it is completely expensive. The other thing is in our decision modulation classification, first of all, we have to identify what's our data distribution. Then we can apply any other methods for machine learning techniques for our classification process. In this case, our signal plus noise case is that Gaussian noise. Therefore, our probability density function is like Gaussian distribution with EXK signal. Then we can use our Gaussian distribution for classification process. That means we can use empirical, that is simulation curve with theoretical curve for PHK signal, and we can match each of them with some distances, and we can classify each of them. Let's consider a PHK 10 decibel noise, 100,000 samples. There are a lot of 100,000 samples, number of samples. Therefore, in this case, we have to pay a lot of time to identify what is the modulation. Therefore, when we increase our 500 samples up to 500, the empirical curve is more fluctuated like 5. Then when we use our Gaussian kernel as our kernel for probability density function estimation instead of rectangular bin, then we can define kernel density estimation for our classification and in 99% confidence interval by using Golden algorithm. Then we can match each of them for lower number of samples. Therefore, we can match each of them effectively and we can classify them. Next, I invite you to read the deep learning part. Thank you.
Thank you, Nirmal. So let's go a little deeper beyond the basic machine learning techniques and have a glance at a more trending and rapidly developing field, deep learning. Here we have used convolution neural networks, which is efficient compared to the traditional neural networks to address the problem of automatic modulation classification. Moving on to the next slide. When analyzing the pros and cons, we can see why deep learning approach is more applicable for our scenario. It stands out compared to other methods as we don't need manual feature extraction, unlike in above discussed methods. Instead of human design features such as cumulants, CNN can automatically mine and generate deep features itself. They are also very robust against translation, scaling, etc., as CNN is capable of preserving spatial features. Requiring a vast amount of training data, which is a fundamental requirement in DL, is one of the negative points of CNNs, but this is not a challenge in our application due to the large amount of communication devices available. Moreover, the major challenge is the model training time, which extends to a long stretch of hours. This is computationally expensive and exhaustive. But the inference only take milliseconds, so this doesn't affect our ultimate goal. Moving on to the next slide. I'll now describe the initial step of CNN image preprocessing. Here, what we basically do is converting the signal samples from complex domain to pixel domain. First, we take the constellation diagram.
You have 1 minute remaining.
First, we take the constellation diagram of the modulation scheme and convert it to 3 different enhanced gray images as shown here by using a mathematical model called exponential decay model. Each of these represent one channel of the final RGB image called the 3-channel image, which is the input to the CNN model. Moving on to the next slide. This is a collection of 3-channel images that we obtained using the above mentioned process for different SNR levels and 4 modulation classes. As you can see, for low SNR levels as 0 dB, the image gets distorted and result in low classification accuracy. Moving on to the next slide. For performance evaluation, we have used AlexNet model, which is an existing CNN architecture. As you can see, the classification results are above 70%, which is very promising, but long training time of 10 hours makes it a painful process. Therefore, we propose a novel CNN architecture to reduce the training time. Moving on to the next slide. In our proposed model, we use a low resolution image of 36 by 36 instead of the high resolution image in the AlexNet model, and use a small architecture with fewer layers. As you can see, the performance is not degraded but has slightly improved. Moving on to the next slide. In comparison, our new CNN model has reduced computational complexity and thereby the model training time, and most importantly, outperforms the AlexNet model as shown here in this graph. Moving on to the next slide.
Good team. Okay, so you have reached the summary. I think we can move on to the questions with the judge panel.
Sure. Hi team. First of all, good presentation, and I have a couple of questions. Do you have a slide where you compare this traditional approach accuracy versus the CNN approach accuracy?
This one is the machine learning accuracies.
And the bottom one slide has deep learning accuracy.
And in CNN, how many layers you have used in terms of the different layers?
We have used 3 convolution layers and 3 layers as you can see in this diagram.
Okay. How do you reduce the overfitting is happening now? Typically, it's happening in CNN. So how did you actually reduce the overfitting?
In AlexNet case, first of all, we use AlexNet that the large in this case, the AlexNet use Adaptation optimizer. Then in our approach, we use the data optimizer. The optimizer is very huge effect to reduce our overfitting case by getting small number of converging time steps, and so that when we optimize our conversion.
We use the early stopping method as well.
Sorry?
Early stopping method in the library, we have that method to use.
And also one question. So have you used batch normalization?
No, we haven't used that.
Okay. And one last question. And you said that in order to you had it took like 10 hours to train, and you want to reduce the time, and you use like different image sizes, right? Basically, instead of
yeah, AlexNet case. In AlexNet, we have to stay 10 hours to training process, but in our proposed neural network, we can train our neural network in 1 hour. Yeah, we can for low number of resolution, but we can get previous accuracy also. Therefore, we think we introduce neural network.
But have you considered this max pool, adding max pool layer to the neural network as one of your convolutional layer in order to do some kind of dimension reduction?
Yes, we also use max pooling layers as well. Yes,
both occasions.
Yeah. We use a 2x2 filter and a 2x2 stripes. Max pooling layers.
It is basically a combination of convolution and the max pool layers and the dropouts, right? That one layer consists. Cool. That's all, Chamodi.
Thank you.
Thank you, judges. This marks the end of the
Thank
Q&A
you.
session. Thank you, team classifiers. This again was an interesting presentation in both,
Thank you.
in which both machine learning and deep learning techniques have been tried out. So, well done, team. Just before I move on to the next presentation, I would like to once again remind the spectators to keep yourselves muted and keep your cameras turned off so that the presenters will not be disturbed. So moving on to our fourth thesis presentation, this is titled as The Impact of Socio-Economic Characteristics of Shoppers on Retail Store Choice Decisions, Results from Multinomial Logistic Regression Modeling in Sri Lanka by Vithanage Shashikala. She is from Bachelor of Science in Town and Country Planning, University of Moratuwa. In this research, she discusses how the store choices are impacted by individual characteristics and expectations, and how the retail businesses can make use of this information when establishing new stores. Unfortunately, Shashikala is unavailable today. She has informed the organizers that she will not be able to make it. So we will be screening her recording, recording of her presentation now. I think, yeah, so, okay, great. We can see the screen.
Hello everyone. First of all, I would like to thank the organizers of this event for giving me this opportunity to present my final year thesis. First, let me introduce myself. I'm Shashikala, a graduate from University of Moratuwa. The title of my thesis is The Impact of Socio-Economic Characteristics of Shoppers on Retail Store Choice Decision, Results from Multinomial Logistic Regression Modeling in Sri Lanka. Actually, I should say that this is only a part of my final year thesis. Let's begin with the need of the research. Actually, I was inspired to do this research in my final year because of the experience I had as a trainee project executive at JK Marketing Services Private Limited, which is under John Keells Group. So when it comes to the retail sector in Sri Lanka, it is really diversified. It offers the consumers a variety of retail store choices such as economic centers, public markets, sathosa, individual stores, supermarkets likewise. Therefore, a consumer select a store choice as a result of a process whereby information of various alternatives is evaluated. But when it comes to the planning of different forms of new retail stores, in practice, normally the planners or the property developers mainly consider few factors such as location, distance to the population catchment, and their income levels. But the socio-economic characteristics of the shoppers are less focused, or the perceptions of the shoppers are not considered when deciding the new retail stores. In order to address that problem, I developed my research objective as to investigate the shopping behavior of grocery retail shoppers based on the socio-economic characteristics of the individual shoppers. So this research is actually important for when deciding the correct retail store combination in a city, for balancing of demand and supply of retail facilities, to provide place-based planning interventions, and finally for capturing the natural behavior pattern of the shoppers. In the literature review, I found that there are two approaches to find the shopping behavior, such as descriptive deterministic approach, explicative stochastic approach. In my research, I followed explicative stochastic approach due to the limitations of the descriptive deterministic approach. The limitations are There are unrealistic assumptions regarding the shopper's selection of closest opportunity, negligence of factors affecting the store choice decisions other than distance, requirement of vast amount of data, limited applicability, inability to capture the actual behavior of shoppers, and complexity of that method. This is how the scholars have conceptualized the decision process by consumers when selecting store choices. They first look at the store choice options available and their attributes, then assign weights to the attributes and to the store choice alternatives. Based on the weights, they rank the store choice alternatives, which finally define their shopping behavior. Actually, this whole decision-making process depends on the socio-economic characteristics of the shoppers. Based on that, I have developed the conceptual framework of my study as follows. A consumer decides where to purchase goods and services by assigning weightages to the store choice options available based on the socio-economic characteristics. This is the methodology I followed. First did a literature review, then identified attributes of individual shoppers, then selected a case study area and store choice alternatives available within that area, then collected the data through a questionnaire survey, and finally applied to multinomial logistic regression model to derive conclusions. My case study area was Piliyandala. I selected a 2-kilometer buffer zone from Piliyandala town center, and 5 store choice options are considered, such as supermarkets, economic centers, public markets, Satosa, and individual grocery stores, which are available within that case study area. This is the analytical framework I used for my study. Here, the socio-economic characteristics act as the explanatory variable and probability of selecting store choices as the dependent variable. I collected data from a sample of 315 respondents, taking one from each family. When building the multinomial regression model, I used 14 variables as socioeconomic data. Through iterative fitting process, only 8 variables are used for the model, which are significant. Those variables are education level, marital status, number of children have, employment status, house ownership, type of vehicle, age, family size, likewise. When looking at the significance of the model fitting information provides that the model is significant at 0.5 significance level. Let's move into the findings of the research. It reveals that older generation prefer public markets compared to the other retail store choice options. There is a tendency of preferring economic centers when there are higher number of family members. When the number of children in a family increases also, there is a tendency for preferring supermarkets. The consumers who do not have vehicles tend to prefer individual groceries compared to the other retail store choices. More interestingly, men prefer individual groceries than women. Finally, higher the number of years of stay, there is a tendency of preferring public markets. So, based on the findings, I estimated the probability of individual shoppers selecting alternative store choices by using the 2 steps as shown in the slide. Here I have used a real-ground situation to check the reliability of the model. Here are the socio-economic information of an individual. He is a 30 years old male with 4 family members, and he has stayed there for 5 years. Once this information is fed into the model, it predicts that there is a high tendency of this consumer selecting an individual grocery with a probability of 88%. So when it comes to the actual situation, he has mentioned that he would prefer individual grocery stores compared to the other retail store choice options when collecting data. The second highest preference is for supermarkets with a probability of 11%. So when looking at the overall model, this overall model is accurate with a probability of 74%. We have reached the final part of my presentation, where finally it can be concluded that socio-economic characteristics of the shoppers affect the store choice decision. So let's say how this information can be used in practical situations. Actually, by using this socio-economic data of the households in a city, we can predict the right combination of retail firms required for that city. So we can ensure that the right combination of retail firms are located at the right places when shaping a city. So this can be used as an alternative approach to model store choice behavior of the shoppers. Further, we can evaluate the viability of new retail developments and make adjustments to existing retail structures. So we know how the shopping behavior would be in a particular geographical area, so that we can make decisions by looking at the socio-economic characteristics of that shoppers. So these are the limitations I faced during my research. These findings can be actually applied to areas similar to the case study area. For the generalization of the results to Sri Lankan cities, it may require the addition of further urban areas. And also, there can be unobserved parameters in this multinomial logistic regression model. So I recommend for further researchers to focus more on validating the results using different case study areas, or else they can research about the evolution of different retail forms and their impact on store choice behavior of shoppers, or choice behavior against proposed planning actions to the existing retail forms. Thank you very much.
Interesting. I hope everyone found that to be very insightful as well. At least I know the Octavians did, especially given the fact that most of the work we do in Octave is around the same retail domain. So yeah, it was one interesting presentation as well. So we can move on to our fifth thesis presentation. This is titled as Objectively Measuring Player Performance in Olympic Weightlifting by Team UOP Elites. The team members are Chamin Jayasooriya and Anandi Karunaratne. They are from Bachelor of Science in Computer Engineering degree at University of Peradeniya. This, I would say, is a unique research area which the team has applied the machine learning technique. They have applied machine learning techniques as well as computer vision in the sport domain, specifically focusing the weightlifting sport. So Chamin and Anandi, I believe both of you will be presenting. If so, if you could please turn on your camera and state your name for an audio visual check, would be great. Maybe Chamin could go first. Yeah.
I'm Chamin. Hope you can hear me.
Okay, great. Can either one of you please share your presentation as well?
Yeah, sure.
Okay, perfect. So before we begin, let me once again remind you the rules. You'll get 12 minutes for your presentation, and I will remind you at the 11th minute, and try to wrap up your presentation within 1 minute after that. And your presentation will be followed by 3-minute Q&A with the judge panel. Okay, you may begin, and good luck.
Thank you. So good morning, I'm Anandi. Me and Chamin will be presenting to you our research, objectively measure player performance on Olympic weightlifting. First, we will see what is the problem we are addressing, then what is our solution, and what are the results we have obtained, and finally, the conclusion. First, let's take a look at the sports industry and how technology is involved there. So imagine you're a coach or a player or an enthusiast of a sport, then you must analyze your player's performance, your opponent's performance, or perhaps you check match highlights and you want to get a summary of a game that could be played for hours. Do you know 367 hours of videos related to sports events are broadcasted in a single day? Imagine how long it would take to process this data manually. So we all know tasks like sports video summarization, extracting match highlights, performance analysis, commentary are done manually. Or you would need special apparatus set up to do these things. But obviously that is not an easy task. Sports is an industry which is expanding financially, generating more opportunities each and every day. So each sport has its own specific set of actions that are based on common human activities. Therefore, we can use technologies like computer vision to identify these actions and hence enhance the quality of the game. This brings us to the question how we can use computer vision to improve the quality of player techniques and sport strategies using computer vision. We developed a solution that can recognize actions done by players in the sport video and estimate his techniques to simply put, since sports are built upon a specific set of actions, we could apply action recognition for video understanding. When it comes to computer vision problems, there are some common challenges that cannot be fully avoided. We can have occluded or truncated objects, cluttered black background, continuously moving and changing camera angles and scales, and color variations. To overcome the said challenges, we have narrowed down our broad scope to Olympic weightlifting. It has minimum occlusion and truncation, uniform scale, uniform brightness and contrast distribution, contains a single person performing the action, and almost no background color. So let me give you a little insight into weightlifting first. Weightlifting is basically a player lifting the maximum weight he could following the given guidelines. It has two categories, snatch and clean and jerk. A player gets maximum 3 lifts in each category. The highest weight lifted successfully in each category will be summed up and it will be used to decide the winner. There are 3 judges who will be judging whether a lift is faulty or not. Majority of votes will be considered to judge the lift. Analyzing the snatch and clean and jerk categories from Olympic official YouTube channel, we have identified the actions that we are supposed to identify. Now Chamin will talk about how we used human action recognition to evaluate weightlifting techniques.
In a nutshell, first we identify actions using open pose from video data, and then we can calculate angles using pose estimation data and based on identified actions. Finally, we estimate the score for the player's actions and other critical parameters like barbell position. First of all, we created the video dataset from Olympic weightlifting footage. Since there are no available video datasets on weightlifting, our dataset has 11 action classes, which we have identified earlier, and it contains 1,570 samples in total. In the data collection process, we try to follow an unbiased way when collecting videos. The data includes videos from both men and women categories, and snatch and clean and jerk from jerk technique, both split jerk and power jerk actions. Then we develop our action recognition model. As discussed earlier, first we extract individual video frames from raw video footage, and then with the help of OpenPOS framework, we got skeleton data of human figures in each video frame. After that, feature extraction and action classification is done using deep learning techniques. Then we have introduced a new scoring algorithm that will be more suitable for players and coaches to analyze their accuracy. As we know, the weightlifting scoring system is more like a binary situation. 3 judges say whether your lift is faulty or not. The algorithm we have proposed will tell how accurate your lift is. What we did was get information on the body angles and position and get a weighted average depending on how critical the variable is. But by analyzing the literature on the relationship between body science and weightlifting, we have identified what are the important measurements when it comes to weightlifting. We used a skeleton-based model to identify positions of joints, and using that data, we were able to calculate this knee angle. When it comes to a lift, the knee angle in the setup position is really important, and it affects the whole lift. Bar angle should be horizontal as much as possible while lifting, because it might affect the balance if the angle is too high. Bar position and bar velocity can be used for calculating power, as power equals force into velocity. Limbs angle at the final position of the lift should be close to 0 degrees, meaning arms and legs should be stretched to maximum for the lift to be a valid lift. These angles are calculated in a 2-dimensional space since we used the 2D post estimation method to work with ordinary videos. Therefore, we interpret these angles to estimate a score rather than giving a raw values. This is our scoring algorithm, where we calculated scores for selected parameters based on the action performing in each video frame, and finally calculated the weighted average of the scores to give an overall score for the whole lift. In this slide, you can see how we used OpenPOS skeleton data to mathematically interpret the body angles and other parameters to estimate a score for a particular action. Then we created another small data set that contains Olympic medalists' videos, which was used to calculate baseline values. We have made the assumption that techniques of Olympic medalists have more accuracy here. We determined optimal angles using medalist dataset to estimate scores for non-medalist players. Here are the optimal values we got for parameters in our scoring algorithm. Next, let's move on to the results and analysis section. Before presenting results, we would like to show you a demonstration on how our model works. This video is an output from our full pipeline, where players' actions are recognized and then scores were estimated to give an overall score. On the left-hand side of the video, you can see the identified action and relevant score for the current frame. And after the lift is done, this shows the score report and average angles of the player. These are the accuracy report and confusion metrics for the action recognition model. Since our dataset contains videos which show the full body of humans, and since we kept occlusion, truncation, color variation, camera angle variation at a minimum level, the deep learning model has given 94% of accuracy on test data. These are the histograms that show the variation of calculated angles and scores for 16 video samples from the dataset. Here you can see knee angle distribution and bar angle distribution, and then left and right leg angles distribution, and arm angle distributions. And these are the graphs that plot the position of the barbell with respect to the video frames. This is a plot of bar movement in a snatch lift. And this is for a clean and jerk lift. And this is the comparison of two snatch lifts of two players. In this way, you can compare bar movement with other players or with your own previous lifts and analyze them. So to sum up, in this project, we created a weightlifting dataset for action recognition and pose estimation, which is annotated in frame level. We introduced a viable method that can be used in practical situations without using any special apparatus other than a video camera to analyze the quality of a weightlifting player performance using action recognition, and presented qualitative and quantitative results for Olympic Games footage. So thank you all, and special thanks to OCTAVE for giving us this valuable opportunity.
Thank you, Team Alliance. Judges, do you have any questions for the team?
Thank you, Shamoli. Chamin and Anandi, great work, nice presentation. I have some queries around, let's go back to the section where you showed us how you collected data sets. So I want to know more on, like, because you have for the whole work of this, you have collected your own data set. In the terms of annotation, how did you judge the annotations? Did you annotate the data set as well, or what was your exact process of collecting the data set?
Well, we collected the video footages from official YouTube Olympic channel, and then we trimmed those long video sets and got the exact lift from the initial to the final position of the players. And from those trimmed videos, we annotated we annotated like which action goes to for a particular time frame, like from 0 seconds to 3 seconds. This is the setup position, and like so.
So how do you, like, when you're annotating, how do you know that this action is good, bad? Like, what the score level you are not annotating at that point?
No, we only annotated the actions. We didn't annotate the scores. Only the actions are classified, and then from the classified actions and using skeleton data, we calculate the angles of the body joints, and after calculating angles and bar positions like that, then we estimated the score.
Okay, no, that's fine. And for that finding the action recognition, you used OpenPose, which was like the open source framework. You didn't train it, right? It was already available.
Yeah, we downloaded a pre-trained model from Carnegie Mellon University, and we used that for pose estimation.
Okay, and the scoring is like your contribution on top of what the OpenPose generates.
And plus action recognition classification.
Okay. And now the biggest question, I think this part you had missed on this whole presentation. When it comes to computer vision solutions, the time taken to arrive at the solution is very important. And because sometimes, like, because it changes the application, sometimes you can do this at real time when the competition is going on. So weightlifting competition is going on, you could do this scoring system on real time. It could help the judges get a report parallelly in addition to what they are scoring. That is one way of doing it. And if the time taken for your solution takes a lot of time, maybe you can't do it real time and you need to process the video later. And what was your the time taken or the performance of the solution?
Well, for training the whole data set, we used high performance GPU on our department servers. Therefore, for training part, it took around like for those total 1,570 frames, it took around 5 to 6 hours. But after the training is done, we can use raw video footages, and then we only have to take the post estimation, do the post estimation, and estimate the scores. For that, for like a 3 minutes long video, it takes around 10 to 15 minutes to do the whole process.
Okay, no, that's fine. Like that is normal. Like doing it real time is a challenge, but it's worth mentioning those because they directly impact the applications. Yeah, that's all I have. Good work, Chamin and Anandi. Thank you.
Thank you.
Judges, if anyone else has any other.
Yeah, I have one question. This is like not regarding the approach and all, but I was wondering whether you scored any failed attempts of any weightlifting. Like what was the scores that you got for any failed attempts of lifting?
Well, we didn't say this is a failed attempt or a valid attempt. We only estimated a score from 0 to 10, and that is for to analyze the actions quality, and we didn't say this is a valid attempt or not.
Okay, so in the when you are analyzing these scores, you scored the failed attempts as well. So in the process.
Well, we actually didn't use failed attempted videos for the testing process, because we estimated the score from initial position to the final position. Therefore, we had to take all the actions and estimate a score. If that was a failed attempt, we would not have to we won't be able to take all those actions and the parameters.
Oh. Understood. Thank
like
you.
for me, the whole purpose is if we take a sub-action we have mentioned here, the snatch category has sub-actions like setup, pull, receiving bar, and stand. In the setup position, the knee angle is important, but in other positions, knee angle is not important. So we can analyze, even if we have a failed attempt, the result will be given according to whether the knee angle was correct at that time. And by analyzing those results, we can analyze what went wrong and all, if we want to.
Okay, yeah, good.
Do you have any other questions, judges, for the team? Okay.
No, we are good.
Okay, thank you, judges. So this marks the end of the Q&A session. Thank you, team UOP Elites, for your presentation. That was definitely an interesting topic, I would say. So I'm just curious to know whether either of you are engaged in that sport.
No.
Okay, that makes it more interesting choosing that domain. All right, I think we can move on to the next presentation. This is our sixth thesis presentation for the day. This is titled as Vehicle Tracking Based on Improved Deep Sort Algorithm and the YOLO V4 Framework under different lighting conditions and inter-vehicle distance estimation using neural network regression. This is presented by the team Metrics. The team members are Shehan Senimiratne, Imali Pereira, and Asini Jayaratne. They are from Bachelor of Science in Electrical and Electronic Engineering from University of Peradeniya. The aim of this research is to provide a solution to existing limitations in the vehicle tracking systems that can be used with efficient traffic management. Shehan, Imali, and Asini, could you please turn on your camera and state your name for an audiovisual check? Maybe I think Shehan could. Yeah, Shehan. Okay.
I'm Shehan Senimiratne.
Imali Pereira. I'm Asini Jayaratne.
Okay, good. Can one of you please share your screen with the presentation?
Sure.
Okay, we can share the screen. So before you begin, let me once again remind you of the rules. You'll get 12 minutes for your presentation, and I will remind you at the 11th minute so that you can wrap up your presentation. And then this will be followed by about 3 minutes of Q&A session with the judges. And for the spectators, once again, I would remind to keep yourselves muted and also turn off the camera. Okay, team metrics, you can begin your presentation, and good luck.
Good morning. We are Team Matrix from the Department of Electrical and Electronic Engineering, University of Peradeniya. Today, we are here to present our work on our project, a deep learning-based framework for vehicle localization and tracking under different lighting conditions and inter-vehicle distance estimation. First, let me give a brief introduction to our project. Vehicle localization and tracking plays a significant role in the area of traffic surveillance systems, where efficient traffic management and safety are the main concerns. Traditionally, localization and tracking have been carried out manually. But as of recent years, with the introduction of concepts such as smart cities, vehicle localization and tracking have taken a new turn. Today, deep learning-based frameworks have emerged as an efficient solution. Now, let me elaborate on the problem background. If we look at what is actually meant by localization and tracking, localization is the process of determining the position of a vehicle in a single frame, whereas the basic idea of tracking is to associate two vehicles in successive frames to identify them as the same vehicle. When we take the existing object trackers, there are some common drawbacks such as assigning false labels to vehicles and switching labels and IDs from frame to frame. Another main fault is the inability to track through occlusions where the object is blocked from the view, and the inability to track nonlinear motion of vehicles, and they also perform very poorly under low light conditions. Therefore, our main objectives of this project were analyzing problems associated with state-of-the-art vehicle tracking systems, development of a deep learning-based algorithm for vehicle tracking in unstructured and crowded scenarios, and to extend the implemented system as a data extraction tool for behavioral analysis of vehicles.
Next, let me go through with our methodology. Here, mainly we focused on 3 tasks. First task is vehicle localization and tracking using improved YOLO v4 and deep sort framework. YOLO is a real-time object recognition system that can recognize multiple objects in a single frame. YOLO recognizes objects more precisely and faster than other recognition systems. Deep sort, which is an improvement version of sort, is one of the most popular state-of-the-art object tracking framework today. So we achieved the task 1 by optimizing the YOLO v4 object detector and using the uncentered Kalman filter and improved feature extractor for tracking. Second task is vehicle detection and tracking under low light condition. To achieve that, we have used image enhancement techniques and data augmentation techniques. Third task is inter-vehicle distance estimation using neural network regression. Next, I will quickly go through the steps we followed to do the task 1. First of all, we take the live videos from the live video footage. Then we do the vehicle localization and identification. Then we predict the position in the next frame. Then we do the, by using those predictions, we do the IOU comparison. then we take the feature extraction and do the comparison. Next, using those parameters, we do the cost evaluation. Next, we assign the detections to tracks. Next, we initialize new tracks based on unassigned detection. Finally, we delete the tracks if they have remained unassigned for too long. Next, the task 2, vehicle detection and tracking under low light conditions. Like earlier, we first take the video footage, then we remove the noises, then we apply the data augmentation techniques, and then we apply low light image enhancement. Finally, we localize the vehicles and tracking. The task 3 was inter-vehicle distance estimation. Like previously, we take the live video stream, then we do the vehicle localization tracking, then we sort out the vehicle using Y coordinates, then we do the lane separation, then calculate coordinates for inter-vehicle distance estimation, then we predict the real world distance using the deep neural network. Finally, we display the distances as shown in this figure. So next, let's move into our experiments. This is the second. First, we take the video footage and break down the video footage into frames. Then we manually label them and feed the data into the YOLO V4. By optimizing the training, like considering the two factors like total YOLO average loss and the mean average precision value, by considering these two factors to a certain optimized levels, we can minimize the false detection and minimize the overfitting, and then we can achieve a optimized object detector.
Let me elaborate on the prediction stage. There are two main reasons as to why we use a prediction algorithm: to track vehicles through occlusions and to predict the position in the next frame for association of tracks. Most of the state-of-the-art object trackers use the constant velocity Kalman filter. So we tried to model the motion of vehicles using the Kalman filter. And as you can see, there is a significant error between the predicted motion and the actual motion of the vehicle. This is mainly due to the fact that the Kalman filter is a linear filter and therefore it fails to model the nonlinear motion of a vehicle. So to get a better prediction model, we tried out different prediction algorithms, and as you can see in the enlarged portion, the extended and the uncentered Kalman filters model the nonlinearities with a significantly low error compared to other models. This image shows how the Kalman filter fails to capture the sudden changes in vehicular motion. So it is evident from this that the uncentered Kalman filter produces the best and the closest approximation for the position measurement of a vehicle.
Compare feature vectors is another method to identify similar objects. The deep sort framework is basically developed for people tracking. Therefore, this object tracking method not perform well for vehicles. As a solution, we replace the deep sort feature extractor with AlexNet feature extractor. After obtained feature vectors, cosine distance of two vectors from two frames can be calculated. The logic used here is if the cosine distance is greater than some threshold value, we identify as same vehicle. The threshold value can be changed according to the situation. Here, the next slide, please. Here, this figure shows tracking one vehicle in 14 consecutive frames. The graph shows the cosine similarity between feature vectors in those frames. The blue curve represents the cosine similarity of the deep sort feature extractor, and the red one is AlexNet feature extractor. The graph clearly shows the performance of the AlexNet feature extractor is much better than the deep sort feature extractor. Therefore, we modified the feature extractor of deep sort object tracker using the AlexNet feature extractor. Before, the vehicle tracking framework was trained for daylight conditions, but for low light conditions, the performance of the vehicle tracker was degraded due to noise, blurring, and the low visibility of vehicles. As a solution for the training dataset, we added data augmentations. Here, changing exposure values, adding noise, and blurring were used to improve performances. For further improvements, illumination, map estimation, and RetineX algorithm were used as enhancement for low-light images. Finally, we were able to develop an efficient vehicle tracker under low-light conditions with low false labels and with more vehicle detections.
Inter-vehicle distance is a key parameter used to analyze the behavior of vehicles. For this, we first needed a method to estimate the real distance between 2 points on a road surface using the corresponding distances in video frames. So to model this mapping, we built a deep neural network using Keras, and this image demonstrates the training of the network. To estimate the distances, we first sort the vehicles using y coordinates and group them into lanes using the equations of the lines indicated in red here. Then, by equating the distance ratios to those lines, the coordinates are calculated to measure the distance along the road. These coordinates are the inputs of the regression neural network, and the outputs are the real-world distances.
Next, let me go through with our discussion. This is the two instances where the force label has been assigned for a bike and a car. After optimizing the training, we managed to correct the faulty labels. This is an instance where ID switching has taken place due to the occlusion. Tracking has failed. By using uncentered Kalman filter and the AlexNet feature extractor, we managed to track the vehicles correctly. In here, the first picture represents the image without using any image enhancement or augmentation techniques, where the false label has been assigned. Second figure is the output where we used image enhancement and data augmentation techniques. In there, we managed to assign labels correctly. This is our result for the task 3. We display the inter-vehicle distance estimation in centimeters.
So to summarize our key insights, detection errors were minimized by the introduction of the optimized detector. Prediction errors were minimized by the uncentered Kalman filter, thus vehicles could be tracked accurately through occlusions. IDSHs and tracking errors were reduced by the addition of the uncentered Kalman filter and the AlexNet feature extraction network.
You have 1 minute remaining.
False labels were minimized and tracking was improved under low light condition by data augmentation and image enhancement techniques. Overall, we were able to develop an efficient vehicle tracker with a high level of accuracy. An algorithm was developed for inter-vehicle distance estimation using regression neural network. This concludes our presentation. Thank you.
Thank you, team. Judges, do you have any questions for the team?
Yeah, I've got some questions. So thanks for the presentation. It was very, very interesting. One thing I want to know is, so what is the sample size of the data that you've used?
For the object detection, we used 3,000 vehicle images. From
Okay.
that, 2,500 were the training set and the rest was the test set.
Okay, and what about for the distance estimation?
For the distance estimation, we used the size of the entire data set was 1,000, and 800 of it was the training data set, and 200 we used for testing.
Okay, okay. So so you used 800 images towards the regression neural network classifier, right? Just to,
yes.
Oh, sorry, the regression neural network to get the distance estimations. Okay. And you mentioned earlier in the presentation that you manually annotated objects, right?
Yeah.
So this is the 3,500 images that you had.
Yeah.
Okay. What was the sort of, did you all do any like verification checks for that? How did you all go through the annotation process?
We did it like this. In a single photo, single frame, we had like 15 or 10 to 15 vehicles. So the verification is done by us, not from the others. So we label them manually and label them as either van or bike, or we had 6 classes.
Okay, okay. Just out of curiosity, did you all have like maybe 2 or 3 people doing like different sets and then cross-checking each other's work? Or was it just like split, you know, like 20% you do, 20% the other person does, so on?
The first part, up to the tracking, we did 3 of us all together. Then the regression, the distance estimation part was done by myself and Imali. And the image enhancement techniques under low light conditions was done by Asenija.
Okay, so were there any cross-checking of annotations? So what that means is that you get what I'm asking, right? Like, so for an example, if you annotate like 500 images and Imali annotates another 500 images, do you all cross-check each other's work?
Yeah,
we did check each other's work.
Okay, good. Because if I think this is sort of like verifying annotation is I think another key component. And I have 2 other questions. One is you mentioned that you switched the feature extraction component, yes, in DeepSort. Here, and you said that it did really well when you switched it to AlexNet. What was the sort of like, how many different types of like, what was the sample size like when you did that, made that decision, you know, like that it's doing really well?
So we actually checked it with about 200 images. Yeah.
Okay. And so your accuracy has improved quite significantly, right? What is the current state of the art in global research?
What is the state of the art object tracking network that's being used today? And YOLO V4 is the state of the art localization technique that's being used. But DeepSort doesn't really perform well for nonlinearities and occlusions and things like that. So we tried to improve those aspects.
Okay. So were there any other research teams that were doing object tracking improvements? Did you all notice, like not pushed out sort of libraries like DeepSort and so on, but like they were building on that and then adding extra layers like the way you all are doing and getting some level of like maybe 5 points increase and so on?
Didn't really notice anyone that have added nonlinear filters to DeepSort, and the feature extraction network has not been changed by the others.
Okay, cool. Very interesting. Thank you.
One question. What is this place, by the way? You take this live feed.
It is the place near the Kandy New Road, near the Amaya Medical Center.
You annotate the data set for the distance, right? So all the distance come from these locations, right? All the data that you have collected.
Yes.
Have you record like anything by changing the angle of the camera and try like generate like different set of images? Because when the angle changes, your XY coordinate changes. So have you
it is the next step of our project. So we are working on it.
Currently, we are assuming that it's still camera.
Judges, is that it? Are there any more questions for the team? Okay, I believe that's it. Thank you, judges. So this concludes the Q&A session. Thank you, Team Metrics, for your presentation, and it was an interesting Q&A session as well. So again, that was a great research as well. Good use of novel optimization techniques in improving a solution, a problem, solution for a problem that I think we all face on a daily basis. So interesting work. Okay, so far we have witnessed 6 equally interesting presentations addressing a variety of different domains like telecommunication, retail, sports domain, and even indigenous medical domain, and applying state-of-the-art techniques like deep learning, machine learning, different optimizations, and even forecasting methodologies. So for one thing, I know for sure that it's not going to be an easy task for the judges to select a winner. And we also have 3 more interesting research presentations remaining. So we are moving on to the last 3 presentations of our symposium. We'll start the 7th presentation for the day. This is titled as Determining the Invoicing Dates for Raw Material Order and Finished Product Dispatch Using Neural Networks and the Exchange Rate Volatility by Janit Veerasinghe. Janit is from Bachelor of Science in Transport and Logistics Management degree from University of Moratuwa. So this research is predominantly in the domain of supply chain and specifically how it can be impacted by the fluctuations in the exchange rate. So Janit, could you please turn on your camera and maybe state your name?
I'm Janit Veerasinghe. Can you hear me?
Yes, that's very good. Janit, you can go ahead and share your screen as well.
Okay, sure.
Okay, all good. So once again, reminding the rules, you'll get 12 minutes for your presentation, and I will remind you at the 11th minute. So your presentation will be followed by a 3-minute question and answer session with the panel of judges. And Janit, you can begin. Good luck.
Thank you, madam. I'm Janit Veerasinghe, and my research topic is determining the invoicing dates for raw materials and finished product dispatch using neural networks under exchange rate volatility. If I explain my research problem, these days USD LKR fluctuation is a hot topic in Sri Lanka. In my research, I have focused on its impact on Sri Lankan companies. Sri Lankan companies engaged in international businesses are highly affected by this exchange rate fluctuation in the foreign exchange market because of this floating exchange rate prevalent in Sri Lanka. As you see in this graph, we can observe high volatilities in USD LKR exchange rate within short periods of time. So if we can forecast this exchange rate, we will be able to incorporate the best dates for imports and export to generate an additional revenue to the company, as well as it will be a cost reduction. Then why we selected this USD LKR exchange rate? Why not Chinese yuan or British pound per LKR? It's because according to the World Bank reports and the Trading Economics website, the main trading partner of Sri Lanka is United States. It's about 25% share. So Sri Lanka have to mainly deal with USD, and other currencies also depend on this main currency, United States dollar. And we did literature analysis on mainly 5 topics. How does supply chain cost impact the financial management of the company, and how does the exchange rate affect international trade, and strategies used by firms to mitigate the exchange rate risk, and factors affecting the exchange rate volatility, and the methods of forecasting the exchange rate. Through literature, we found that current practices to mitigate the exchange rate risk as hedging against forward market and invoicing in domestic currency, and country as a whole, it can go to the strategies like pegging to the most trading currency. But all of these strategies are to avoid the impact of exchange rate volatility. So we identified the research gap as firms are not using a strategy for deciding the invoicing dates for raw material imports and finished product exports to generate an exchange rate gain by forecasting the exchange rate. So we developed two research questions: what is the best forecasting model to predict the USD/LKR exchange rate volatility, and how to decide the invoicing dates for raw material imports and finished product dispatch based on exchange rate volatility. With that research questions, we set our research objective to find the best exchange rate forecasting model to incorporate with business decisions in manufacturing firms that import raw materials and export finished goods to decide the invoicing dates for imports and exports. Through literature, we found several factors affecting to the exchange rate fluctuations. Among all of these, there are many researchers who have explained the impact of news events to the exchange rates, but all of these factors are not freely available. So if we use all these factors to develop a forecasting model, it will not be useful for practical application in companies. Therefore, we selected these marked factors which are freely available to forecast the exchange rate. And literature suggests mainly two exchange rate forecasting methods, fundamental analysis and technical analysis. There are many methods of doing this, but again, recent literature mentions because of the complicated nonlinear features and diversity of input parameters of these financial data, these methods are not successful alone. So it suggests neural network approach to deal with this financial data because it can handle both fundamental and technical data. Through literature, we found several statistical forecasting models and neural network forecasting models for exchange rate forecasting. Among all of these, literature suggests vector-to regression as the best statistical forecasting model, and long short-term memory neural network, that means LSTM neural network model, as a best model to forecast exchange rate. With the previously mentioned data, we developed two data sets. Dataset 1 is with exchange rate data time series data and macroeconomic time series data, and dataset 2 is with all the data in dataset 1, and additionally categorical data of news events of USA and Sri Lanka, and dataset was with 1780 daily data points, and we took 97% as training data and 3% as test data. First, we developed the vector-to regression and LSTM model. Then the dataset 1 was fed and selected the model with best accuracy. Then that selected model is fed with dataset 2. Then found that model with found the model with best accuracy. Using that model, exchange rate is forecasted for 1 week ahead. Then the predictions were plotted with actual imports and export dates. Finally, analyzed the invoice dates from the company. This graph shows the test predictions of vector-to regression model. In graph 2, blue color line shows the predictions. You can observe that the predictions are highly deviated from the actual exchange rate. This graph shows the test predictions of the LSTM model with dataset 1. Again, here blue color line shows the predictions. We can see that that comparative to the vector-to regression model, predictions are more closer to the actual exchange rate. This graph shows the LSTM prediction with dataset 2. Again, blue color line shows the predictions. We can observe that the predictions are better than LSTM predictions with dataset 1. In this graph, we can observe all three predictions in one figure. Black color line is the actual exchange rate, and green color line is the vector-to regression prediction. We can observe that it has highly deviated from the actual. So ash color line is LSTM prediction with dataset 1. It is plotted closer, but it haven't identified the frequent fluctuations. Yellow color line is very closer to the actual exchange rate, as well as it has identified the fluctuations also. So when we compare this graph, we can identify that the LSTM model developed with dataset 2 is with the best accuracy. And when we compare the evaluation results, LSTM model 2 is with the least error values and the highest correlation and mean directional accuracy values. So we decided that the LSTM model developed with dataset 2 is best for forecasting an exchange rate. When we observe the sensitivity analysis chart, we can observe that the 2 days prediction model and the 3 days prediction model delivers the least error values and highest correlation values. But in the practical business scenarios, it is more beneficial in forecasting exchange rate for 1 week ahead. So we selected the next best model, 5 days prediction model for import and export date analysis. To analyze the export dates with the LSTM model, we forecasted the exchange rate for the period that we have the export data from the company. Then 5 days predictions are plotted with the actual exchange rate. Then we selected the date with highest predicted exchange rate. Then we, on the same graph, we plotted actual invoice dates for exports by the company. You can see here that if the company has been invoiced all 3 orders on 9th of September, they could have gained an additional revenue. As same as earlier process, it's possible to choose the date with lowest exchange rate for import raw materials. As you see in this graph, if the company has been invoiced the order on 2nd of September, they could have reduced the cost of the order in LKR. If we analyze overall results of deciding invoicing dates for LSTM model forecast, if the company used the forecasting model, they could have gained a 76% success rate in deciding invoicing dates for exports and 82% success rate in deciding invoicing dates for imports. It's in average 0.18 LKR per dollar gain in exports and in average 0.09 LKR per dollar cost reduction in imports. Finally, if we analyze key insights and the results of the research, analyzing results confirms the literature mentioning neural networks perform better in financial predictions than statistical forecasting models. We can see in this chart that vector regression prediction is highly deviated from the actual exchange rate. And as the second point, results of dataset 1 and 2 confirms the literature mentioning macroeconomic and geopolitical news releases impact for the accuracy of the forecasting model. We can see here that yellow color line shows more fluctuations, that is LSTM model developed with dataset 2 that with news releases of USA and LKR shows high accuracy in prediction. And sensitivity analysis confirms the literature mentioning short-term prediction models deliver better forecasting accuracy. And LSTM neural network model trained with freely available macroeconomic data delivered better exchange rate forecasting model. So it allows companies to develop and use exchange rate forecasting models for daily business transactions and increase revenue. It will help to increase revenue in LKR when exports, and it will reduce supply chain cost of imports. That's about my presentation, and thank you.
Thank you, Janet. Judges, do you have any questions for Janet?
Yeah. Hi, Janet. Great work, and like we need to applaud your you being brave to take such a problem, because there's so many variables that contribute to the exchange rate, and it's not easy to model that. So it's fine if the results aren't really great, but the attempt is what that matters. I'd like you to go to the section where like you had plotted the results, like on a graph you had shown with the previous one. You passed it, the one with the red, and the next one.
Answer?
No. The bar chart from top and below, and there were red marks.
Okay. Listen.
Yeah. So here, like, correct me if I'm wrong, but you are trying to say that on average you are gaining when you're on export, you are getting a 0.18 LKR per USD, and when you're importing, you're getting a 0.09 LKR per USD on average. Is that?
Yes, sir.
And so these the ones on the red are like the losses that you are making.
Yes.
And the ones on the green, okay. So like how, like, was this simulated, or like how many iterations did you do? Because this is eventually no model can guarantee that you will constantly make a profit, because we need to look on a long-term basis, right? So this is interesting, but how many simulations did you do, and what are the considerations you did before arriving at these numbers?
All the parameter tuning in neural network models are trial and error. So I did so many changing neural networks neurons, number of neurons, and batch sizes, and tested all the models until it delivers a better result.
On the same data, is it like this? Okay, like that's a good attempt, but the issue there is you can't generalize it, right? So maybe what we would have liked is for you to do all the hyperparameter tuning on one data set and compare it on multiple data sets, like could be validation, could be test, or could be a simulated thing, so that we can on one data set saying that 0.18 LKR per USD might not be the same on a different data set, could be on a validation or test data set. So before doing that, it's okay to do the hyperparameter tuning on one, but for the rest you need to at least simulate and see how much your profit or loss you are making on them.
Yes, sir. In sensitivity analysis, I showed 2 days prediction model and 3 days prediction model deliver better results than this. But when we use those results in practical business applications, it's no use of forecasting for 2 days and take a decision. That's why I took 5 days prediction model. That means I tested it for several days also, and kept the best result at 5 days prediction model.
Okay, no, this is good work, but I think if you have more time or if the project has not been completed, it's worth looking into other features that goes into these because it's not, I don't think it's a simple problem to solve, and definitely more features inside, like more data points would help solve. Plus, maybe worth adding, maybe simulating and checking on different data sets, so that you can show that, okay, my model might not give you the best every single day, but on average for 3 months, for 6 months, I have shown that you will make profit of this amount. So then that is more convincing. But this is a great first step, I'd say.
Yes, sir. Thank you.
Thanks,
for
Anita.
Do we have any more questions, judges?
Yeah, I have a question as well. Janith, what sort of macroeconomic factors did you include here?
Yes, madam. I selected freely available macroeconomic factors. That means daily data should be available for daily forecasting. So I took call money trades in stock market, in purchases and foreign sale.
Sorry, stock market data and?
Stock market, foreign purchases and foreign sales.
Foreign what?
Foreign purchases and foreign sales.
Foreign sales. Okay. Cool. Okay, cool. Thank you.
I don't have a question, but I have a comment. Like I saw that you did test and control 97 and 3%, but it's better to have like at least 20% for your test group. So I mean, when you do the future works, try to have like 80-20 combination at least.
So it's because at the end of the data set, we can see high volatility fluctuations in the exchange rate late 2019. So I incorporate that data also to train the model. That's why I took 97%.
Yeah, because of you don't have like enough data, right?
Yes.
Cool.
Okay, thank you, judges. So that concludes the Q&A session for Janet. Thank you, Janet, for your insightful presentation. And I think you also had the opportunity of getting some valuable feedbacks from the panel of judges.
Thank you very much, panel and madam.
Okay. Thank you once again, Janet. So we can move on to our 8th thesis presentation, We're actually a few minutes ahead of our schedule. But we can move on to our 8th presentation. So I think the last presenters, y'all can also be prepared since we are running a bit ahead of our schedule. Okay, so let us move on to the 8th thesis presentation, which is titled as Recalibrating Retail Store Inventory and Service Levels, Considering the Presence of Credit Card Promotions. The presenter is Randula Jayasinghe. He's from Bachelor of Science in Transport and Logistics Management degree, University of Moratuwa. This research basically provides a framework to determine reorder levels based on the sales uplift due to credit card promotions. Randula, could you please unmute yourself and state your name, please?
Hi, I'm Randula.
Okay, all good. Please go ahead and share your screen. Cool. We can see the screen. Randula, once again to remind the rules, you'll get 12 minutes for your presentation. I'll remind you at the 11th minute, and at the 12th minute you need to conclude your presentation, and it will be followed with about 3-minute Q&A session with the judges. Okay, you can begin. Good luck.
Hello, I'm Randula Jayasinghe. Today I'm going to present my research thesis, recalibrating retail store inventory and service levels considering the credit card promotions. Dr. Dilespera supported and guided me to complete my study as the supervisor. As for the topic says, my study is to identify a new way to calculate the retail store inventory level and the service level. Let's go into the roots. What is retail? Do you know that retail is a French word? Yes, it is. The retail means the breaking bulk into small pieces in French. Why retail is so important to us? Because the retail store is the first consumer interaction point within the supply chain. The retail industry is a so competitive one because there is a razor-thin profit margin. So therefore, every customer counts. The retail store operations therefore need to be optimized and well streamlined. We can the retail store operations can be divided into two main parts: backroom area and the front floor. The main task of the backroom is transporting warehousing and shipping good to the front floor. The front floor consists with operations like promotion, product assortment, and the product display. So considering all these factors by using the Dr. Chamin retail operation framework, so there are main three parts of the framework: entities, which mean the stakeholders, decisions, and the store performances. So we found the products can control the consumer behavior within the store, and the products can be totally controlled by the store management. So that leads to affect the retail store decisions that are promotions and inventory. It happens the product promotion accelerate the stock event by 9% to 11%, and it affects the store service level as well. One study showed that increasing only 1% of the service level excel 11% of sales. So what happened if the service level decreased by 1%, or what happened if the service level drops when there's a promotion? There's a huge hit on the sales. So I hope everyone is getting these type of promotion messages frequently. So do you ever think why the retailers are so keen on sending these promotion messages, especially targeting on your credit card? In the modern era, the retail promotions are mostly based on cards, credit cards, debit cards, and the loyalty cards. Among those, the credit card drives more sales into the source because of the overspending attributes embedded with the credit card users, and it leads to increase the store service sales by 200%. But this at the same time they increase the stock out event as well. So due to this, the 21% of the consumers are switching the store, and it affect the store service level badly. So we found 72% of the stock out events are happening due to the inaccurate ordering, wrong quantity at the wrong time. So therefore we conclude the inventory level and the service level get affected most in the presence of the credit card promotion. So this is our research gap, and we are going to address these two areas in our study. So we developed the first research question by targeting the inventory level. That is, what is the effect that credit card promotion made for the inventory level. As the second research question, we consider the service level instead of the inventory level as per the first question. To achieve those questions, we use two research objectives. First one is to investigate the likelihood between the stock out events and the credit card promotions, and the second objective is to build a replenishment model considering the credit card promotion effect. To achieve those objectives, there are methodologies. By critically analyzing those methodologies under these criteria, we selected two. Those are case study approach, case study approach and an analytical approach. The case study approach will help to investigate the problem in depth, and while the analytical method helps to build a complex relationship within the variables. So this is how we used our selected methodologies in our case study. First, we break our task into like this. First, we get the data and we build a machine learning model to predict the stock out event probability while achieving our first research objective. As the third task, we analyze the impact of the inventory level. It provides the answer for the first research question. As for the fourth task, we derive the relationship between the reorder points and the predicted stock out probability. And as the fifth task, based on that relationship, we build a replenishment model while achieving the second research objective. Finally, we assess the service level of the store using the build replenishment model, and it answers the second research question. So we conduct our research using the publicly available data on Kaggle, which represent the retail store data located in USA. Due to the COVID pandemic issue, we were unable to acquire the local industry dataset. So the dataset consists with these attributes: SKU listing, promotional calendar, point of sales data, and the inventory data. So we use the RStudio for exploiting analysis and the machine learning model building, and we use a Minitab to develop the nonlinear regression. And this is how we develop the machine learning model. First, we clean and do the basic exploratory analysis and deal with the missing values and do the feature engineering task. And we second, we split the data set into training and testing, and then we develop the machine learning, three machine learning models: logistic regression, naive Bayes, and the random forest. Then we evaluated all the models using the ROC curves. Then using the best model, we predict the stock out event probability. So these are the results of the ROC curves, and the random forest has the best AUC values. So it used to predict the stock out event probability. So we evaluate the stock out event probability for instances where with and without the credit card promotions, and it can conclude that if there's no credit card promotions, the stock out event probability is about 0.82%, but with the presence of the credit card promotion, that number increases up to 81.83. So then using the predicted stock out event probability and the reorder points, we derive the relationship with them. First we calculate the optimal order quantity and the order frequency level using the economic order quantity model, and it clearly shows that with the presence of the credit card promotion, it need to order more within a shorter period. Therefore, the maintaining the greater reorder point than usual is a must. So, so using a traditional replenishment model that does not give it. So this phenomenon leads to more stockouts and ultimately losing customers. So reorder points represent a safety stock level. So let's think like this. So if you are a stock owner, so if you don't have stock, what happened is to your stock out event probability, it becomes 1. That means that definitely there will be a stock out, right? So what happened if you have the infinite of stock? That means you never face the stock out scenario. So the same logic is used to build a replenishment model between the delta and the P. So after defining the basic relationship, we develop the nonlinear regression by the feeding data into it, and we derive the regression achieving the mean square error of 0.095, and this is the relationship. Finally, we convert the section which contains the P, that initially that's a probability, and we convert it into a units using the sigma DL, and then we derive the replenishment model which contains the credit card promotion effect. Then we calculate the cycle service level for the S1 and S2 reorder points, and it concludes that the replenishment model that we build with the presence of credit card promotion increases the service store service level by 0.78. Finally, we found that credit card promotion effect the store inventory level by generating the stock out event, and it occurrence probability increases up to 81.6%, and the credit card promotion affects the store service level by reducing the service level by 0.78%. According to the literature, increasing 1% of the service level leads to excel 11% of the sales. If the if the service level drops by 0.78, which is almost 1%, it will affect the sales badly. So in order to mitigate this issue, in our study we suggest a new replenishment model. So that is my presentation. Thank you, and this is time for question and answers.
Thank you, Randula. Judges, do you have any questions?
Yeah, I have a question. Can you go back 2 slides? Yes. What does this graph indicate again? This one here, S1 and S2?
Yes, the S1 and S2 indicates the S1 is the general, we are using the reorder point, and S2 is the we newly generated reorder point by considering the credit card promotion effect.
Okay.
Yeah.
Sorry. Okay.
Yeah.
You have, okay.
Yeah. So for this, we calculated the cycle service level for the previous, like a traditional reorder point level, and the then heavily we derived reorder point, and for the S1, the so with the different, we said that the with the different, it indicates the new reorder point increases the store service level by 0.78.
1.78. Okay, nice. And in the, you said you got the Kaggle data set, right?
Yes.
And this was for the first 3 months of 2019.
Yes. Yes.
How many promotions were there in that data set, like credit card promotions?
So like you are asking the only the credit card promotion
As a
instance?
percentage, like out of all, like
okay, credit card promotions were like 40% of the data.
40% of all the things. Okay. And you mentioned that because of COVID, you were not able to get local industry data points. Yeah.
Yes, like we firstly had a agreement with the company, which is a retail company, but with the COVID arises, it terminated. So then we moved into the data set, and we to get the data set, we define a matching score by using the previous literature, and we go through like 7 data sets, and according to the matching score, we selected this data set to for our study.
Okay, very cool. And can you go back also to the equation in which you're computing that stock out rate?
This one?
No. Just ahead. Sorry. Okay, yeah, this one. Okay. So here the stock out probability that you're doing, and you've selected. You said that the random forest is doing the best. Yeah.
Yes.
Okay, and the features that you have used are these ones?
Yes.
Product type, category, unit price, promotion type, and discount magnitude. Okay, did you test out any other features as well?
Like the due to the scarcity of the data, so and the what we derive from the literature, so these are the give me a second, the SKU listing, post data, inventory data, and the promotion data are used for the similar kind of studies. So we took the data set which consists those kind of data points in it. So due to the data scarcity and due to the COVID pandemic issue, so we only use these variables to build the model.
Okay, and you're predicting basically the availability of stock, right?
Yes.
So in a sense, you're predicting demand.
No, not the demand. Whether the product, whether the product is going to be a stock out or not.
Yeah, but that is predominantly dependent on two things, right? One is the demand, and the other one is the inbound.
Yes. Yeah.
Right?
Yeah.
You don't have inbound information.
Yeah.
Right? You only have your daily stock levels.
Yes, and the
and you have your sales levels.
Yes.
Okay.
Randula, based on your conversation with Lamana, what I felt was your way, like the algorithm or like your approach has changed because of the amount of data or the quality of data or the level of granularity in the data that you've got. So assuming that you had got the ideal data, what would you have wanted and what would you have done differently? Like at least what you had planned initially and what you couldn't execute.
Yeah. So developing the model. So this is the framework that I build is kind of a common one, but the results can be differentiate with the circumstances. So so if I have the ideal data set, the first I explore what are the attributes that contribute to the Stochastic probability, and then develop a better model, and using that I follow the same framework that I built.
Okay. No, good and good work, Randula, because like the level of granularity you had gone into and like to look into like exact equations were really good. That should be appreciated. And I'm looking like please if you get better data which you could try. I suggest you continue this. It could be something like really great based on the. If I feel like better data would get you even better results with the same framework that you have. So go for it.
Yes. Yeah, the problem was we had the initial agreement with the retailer company, but with the COVID arises that was terminated. So that's the case.
I hope it was not Keells.
I'm just curious to know what.
No, it is not the case.
Okay.
Yeah.
Nice presentation, by the way.
Yeah, very nice.
Thank you.
Thank you, judges, and that concludes the Q&A session. And thanks, Randula. It was an interesting presentation, and I personally found the research to be very interesting because this topic is very much similar to a use case that I'm currently working with my team. So I thought I should mention this because as a researcher, you might be happy and you might also be interested to hear that here at OCTAVE, we actually make use of such solutions to solve real-world problems in the industry.
Yes,
very interesting.
Thank you.
Okay, we have reached the final presentation for the day. This is blending behavioral factors and task sequences for efficient warehouse operations by Kasuni Veerasinghe. She's from Bachelor of Science in Transport and Logistics degree, Logistics Management degree at University of Moratuwa. So this research applies human behavioral analysis in warehouse management to assess the worker performance. An interesting application of behavioral analysis, I would say. Kasuni, could you please turn on your camera and state your name for me? Could you please unmute yourself and state your name as well?
Yeah, I am Kasuni Veerasinghe.
Okay, cool. Please go ahead and share your screen for the presentation. Okay, we can see your screen. Kasuni, just to remind you of the rules, you'll get 12 minutes for your presentation, and I'll remind you at the 11th minute. And once you conclude your presentation after 12 minutes, it will be followed by 3-minute Q&A session with the panel of judges. Okay, you can begin, Kasuni. Good luck.
Yeah, thank you.
Good morning. The research on blending behavioral factors and task sequencing for efficient warehouse operations. I'm Kasuni Veerasinghe, undergraduate of Department of Transport and Logistics Management, University of Moratuwa. My supervisor is Dr. Nilas Pereira, Senior Lecturer of Department of Transport and Logistics Management, University of Moratuwa. This is the presentation overview. To have an idea into the study area, let's consider the importance of warehousing in supply chain. Warehousing is important as a location which manages inbound and outbound operations linked to the supply chain nodes, and it increases the visibility through the supply chain. Also, it manages the inventory, manage demand and supply, and maintain continuous production. Warehouse operations follows a series of steps. It includes inbound activities, processing activities, and outbound activities. When considering humans and technology in warehouses, today most of the warehouses are equipped with technological tools to automate operations, especially in third-party logistic providers use technological tools such as warehouse management systems, radio frequency technology, barcode technology, inventory checking systems to increase the efficiency. Even though warehouses are highly automated, the human involvement cannot be neglected. Though the humans are guided through the system, their behavior different from one to another based on their mental, social, perceptual, and physical factors. Based on their decision, they plan routing, stock assignment, order batching, and so on. It creates distinctive outcomes. By conducting this research, it can be understand the effect of individual behavior on performance measures for warehouse operational crews and understand the impact of training instructions in shaping the picking behavior at warehouse. Another objective of this research is to identify the behavioral patterns and factors considered by workers in task sequencing in fulfilling orders at the system-guided warehouse. When it comes to this slide elaborates the summary of literature and research gaps. So the important work has been done in the behavioral operation management area in recent years, but there's a lack of knowledge related to human-oriented tasks and division of human behavior in system-guided warehouses and effect of performance measures and planning decisions for the task sequencing. So when consider the human planning decision, the warehouse management systems along with the technological tools guide the workers to fulfill the order fulfillment process at the warehouse. As an example, in a warehouse which use radio frequency technology, pickers are complete the picking operation using the instructions given by the RF device. So also, training instructions and performance measures also have a direct influence for the planning decisions of the workers. In warehouse, picking operation is considered as the most labor-intensive task. Therefore, the management pay more attention when setting the performance measures for the picking operation. So sometimes pickers are given the instructions about the KPI targets and rewards. So there's a question that the pickers behave differently with they are informed about the KPI targets or not informed about the KPI targets, and also whether the pickers behave differently with the various KPI target levels. So the intention behind the performance measures will shape the behavior of pickers, and the achieved picking rates, checking rates, and the picking accuracy rates will depend on the performance along with their decisions. So based on the research problem, we developed following hypotheses. Hypothesis 1 is there's a significant difference between picking rates before and after informing KPI targets. And hypothesis 2 is there is a significant difference between, there's a significant difference between picking rates when KPI targets are increased phase by phase. There's a relationship between picking rates and check-in rates before and after informing the KPI targets, and or there is a relationship between picking rates and picking accuracy percentage before and after informing the targets. As the research methodology for this study, we selected field experiment as it has a higher external validity over the other methods. So there is a lack of influence from the observers in this method, and participants cannot identify the demand characteristic of researchers, such as the reason for conducting this research. And under this method, it is able to capture the time-based effect. So a field strategy considered with field study and field experiment. Field study is conducted to measure the data in the current environment, and field experiment conducted in changing the condition in the warehouse and collecting data. After completing both field study and field experiment, data analysis was done to identify the patterns in the data collected from both field study and field experiment. So as explained earlier, the field study was conducted in the initial condition of the warehouse. In this period, the awareness about KPI targets is less. Through the treatment of the field experiments, we increased the awareness about KPI targets and established grading system to evaluate pickers under different levels of KPI targets. The grading system, which was established during the field experiment, there were 4 different KPI targets levels, namely A, B, C, and D. If a picker achieve a pick rate of 160, the picker will grade it as grade B. So based on their achievement in the phase 1, the KPI target levels were further increased in phase 2. So the study was conducted in a fast-moving consumer good warehouse, which used radio frequency technology, which is belonged to John Keells Logistics. And the historical data extending across the year was collected from 25 pickers and 25 checkers, and data points focused on dispatch operation. These are the data analysis was conducted using the SPSS software. The preliminary results show the distribution of data, the distribution of pick-in and check-in rates, and the pick-in errors. So average picking rates have slightly increased over the period, and when it comes to the pick-in errors with the check-in rates and pick-in rates, there is a possibility to increase pick-in errors with the increased pick rates and reduce check-in rates. So data analysis mainly we considered under 3 sections. So first one is we consider the analysis of picker behavior with the awareness of picking targets. We used paired sample t-test and repeated measures ANOVA for this. So based on the statistic of the paired sample, we can observe a clear difference between the means of 2 data sets. Also, the t-value is equal to 6.127, which is also larger than the identified critical value. So in the repeated measures ANOVA, we compare the phases separately. So in the T1 and T2 are the phases before the treatment. Like before the treatment, we collected data for 6-month period. In this 6-month period also again divided for 2 3-month phases. So there were 2 phases before the treatment and 2 phases after the treatment. So T1 and T2 are the phases before the treatment, and T3 and T4 are the phases after the treatment. So we compare both T1 and T2 with the T3 and T4. So both results shows that there is a significant difference between the periods before and after pickers are informed about KPI targets. The second analysis was to identify the picker behavior in different levels of picking targets. After providing the awareness of KPI targets, we considered the phases and as well as KPI targets. Based on the results of 2-way ANOVA, there is a significant difference between the phases as well as the KPI targets levels. So when increasing the KPI targets, pickers were able to increase their picking rates regardless of whether they were in the A, B, C, or D grades in previously. The final section of the analysis was to identify the correlation of pick-in rates, check-in rates, and pick-in accuracy percentages before and after the treatment. Before the treatment, R value between pick rates and check rates and R value between pick rates and picking accuracy will denote weak positive relationship. But after the treatment, which means giving the awareness about the KPI targets, the R values denote weak negative relationships. So, which means that they are, after providing information on KPI targets, even though pickers achieved high rates, there is a possibility to reduce the accuracy in this level. So, based on the findings of the analysis, with respect to the research hypothesis as follows. Related to hypothesis 1, pickers achieving lower picking rates when they're not aware about the picking targets, and they achieve higher rates when they're aware about the picking targets. Related to hypothesis 2, pickers can improve their ability to achieve higher rates with the increased target levels. And related to hypothesis 3, the weak negative relationship between pick rates and picking accuracy percentage shows that after the treatment, which indicates there's a possibility to achieving peak rates, which may negatively affect the accuracy of the task. So in conclusion, it can be said that providing
so we have
awareness,
1 minute remaining.
Providing awareness about the picking targets is important to have higher rates in the pickers, but also pickers achieve higher rates gradually with the increased target levels, and therefore, however, inadequately designed performance measures will create dysfunctional behavior in workers. So, as in this example, the workers may increase higher rates. There can be effect for the next steps or the accuracy. So, therefore, the established target should be achievable level, and dysfunctionality should be avoided when planning the targets and measurement schemes. And the findings of this study emphasize that importance of incorporating the behavioral aspects of human, and for the establishing performance measures as well as the planning task. These are the references. That's the end of my presentation. Thank you very much. The questions and comments are welcome.
Thank you, Kasini. Judges, over to you.
I have a question. So Kasini, very nice presentation. So you mentioned that you got the data from John Keells Logistics, right? What's interesting to me is that like the findings that you have is quite easily generalizable, right? Because it picks at, it sort of like proves how you can sort of improve the effectiveness of all human tasks in general, right? Now, when it comes to sort of like warehouse management itself, based on these results that you have you sort of thought about, first of all, have you presented these results to the logistics department? Or have you spoken to somebody who is within that space?
Yeah, I already discussed with the procedure of this research with the executives related to the warehouse operation.
Okay.
Because the warehouse management assigned the warehouse executive for giving the data and discuss about the field experiment in the warehouse.
Okay. Okay. So I think one thing that I would like to pick your brain with is, so now that you have these findings and you have an understanding about how the logistics department works, what would be some of your recommendations that they could do? What, like, so you mentioned that, you know, like having like a staged increase in like targets, right? Instead of like a direct increase, so on. How can you sort of go that one step ahead and come up with like suggestions, like, you know, like, oh, you could maybe implement this kind of process or do this kind of like program to help improve the KPIs of the pickers?
Yeah, that's the reason for which I use for field experiment, because using the field experiment, we can we can observe the actual response from the workers, how they achieve with the different levels of KPI targets, how they gradually increase the KPI targets also. But as you say also, there should be other factors also for since it is human, there are other factors, like if we take one human, sometimes their achieving picking rates also depend on the peers, the achieving rates of the peers also. Sometimes they try to achieve that levels also. So there are various angles of this the behavioral operations. So I basically considered in this research for about the informing management systems like that. So that with that, how we can improve the efficiency of the order fulfillment process.
Okay, cool. Thank you.
Yeah, thank you.
Do we have any more questions? Okay, I believe that's it. Thank you, judges. So that concludes our Q&A session. Thank you, Kasuni, for your presentation. So human behavioral analysis is an emerging research area that's widely being applied in different domains. And I think this is an interesting application of this research area in the retail, because we should look at we should apply human behavior analysis to analyze customer behavior. So, but this is a unique application in which you have used it to analyze the employee performance in the retail domain.
Yeah, thank you very much.
Interesting. Okay, so that's all the presentations for the day. So overall, we had the opportunity of witnessing 9 insightful presentations across various domains. I know it's not going to be an easy task for the judges to select one winner out of these presentations. However, whether you win today or not, successfully completing a research project and getting an opportunity to present your work in front of industry experts itself, I would consider a win. So once again, all the participants, very well done. I wish you all the best. And we're a bit running ahead of time, but I think that's better than running late. So we'll take the 30-minute break as we planned, so that the judges can sort of discuss the winners and tally their marks as well. Okay, so we'll be back at 12:30, sharp at 12:30. So make sure that all the participants will be back at that time, because we'll be announcing the winners. Okay.
Thanks, Chamodi. Hey, quick question. Should we just check whether everyone is available first?
The last time I checked the count, so the count should be fine. Sam,
okay.
If you could please confirm. I think we are good, Namana.
Okay. All right. Well, thank you very much, first of all, everyone, for sort of taking that time, taking all this time to prepare for this symposium, and for really sharing all your research experience with us. I think all of us, like, Arun, Chamo, Ruan, Nishika, all of us, like, we really learned a lot from all of you. And I think that's one of the best things about having symposiums like this, because we can all collectively share knowledge and learn about, what other, state of the art techniques that are happening across multiple different, domains. So kudos on that, and great job, everybody. All of your presentations were really good. The presentation slides were very good. The way you all sort of conducted, had the storyline was really good. And, your sort of like problem solving thinking process and the way you all sort of analyze your results and how you all apply those results in a business context in some of the presentations was also very, very commendable. So kudos on that. Yeah, I think I will. We were talking just kind of among ourselves, just on the top sort of like the research that we thought were really good, kind of stood above some of the others, and I think all of us sort of were able to handpick 3. So the top 3 were, I think, clear. Like we really felt like there was something very sort of interesting and above the above the group. But we were debating on who is going to be like 1, 2, and 3 and so on. But so kudos to everyone, and especially kudos to the top 3 teams. Now I think I will maybe disclose the winners. Maybe Sam, can you share the screen? Yep. Okay, cool. So let's go with the 3rd place first. So in 3rd place, we've got Team Matrix. That's Shehan Sinaviratna, Imali Pereira, and Asini Jayaratne. So this is the vehicle tracking based on improved deep sort algorithm and the YOLO framework. Congratulations, guys. It was very, very well done. I think it's a very big problem to solve, and also a very current one to solve as well. So kudos to you all, and I hope that you all continue doing amazing work in this area. This is going to be like a very silent silent clap, as is with these Zoom calls. Okay, then in 2nd place, we have Randula Jayasinghe on recalibrating retail store inventory and service levels, considering the presence of credit card promotions. So congratulations, Randula. We really felt like as if the framework was well thought out, and even though you were struggling with acquiring a big enough data set, we really felt like as if you thought about the business context and came up with quite a detailed framework that is quite applicable. Also, this was a problem that was something that we had also spent quite some time thinking about. So we're very impressed with the thought process that you had. So kudos, good job. Then in 1st place is Team UOP. Oh, I just got this University of Peradeniya. Okay. The Team UOP elites objectively measuring player performance in Olympic weightlifting. So well done. Again, we were very, very impressed. I mean, I think what really sort of shone through in your work was the fact that you all kind of used a pre-trained model and sort of did more interesting work in the synthesis of that. So you all had a limited amount of data sets, but it was quite challenging to sort of, come up with those angles and, use not having the results of the pre-trained model as the output, but really using that to come up with something even more sophisticated. And I think we also felt that it was really good that you all used, some gold standard videos like this of the Olympic heavyweight or Olympic weightlifters to really sort of validate your method. And I think one point of contention, I would say, I think Ishika mentioned this, is that, to be able to really think about all aspects, not only think about the positive learning, but also the negative learning as well. So I hope that in your future work, you will be able to incorporate that thought as well. So it's a very cool space to be in, and it's niche for now, but I think if you're keep going on in this space, you will be able to extend your research to multiple other sports as well. And even I think in terms of rehabilitation, this sort of work would be very, very applicable. So congratulations, very well done. Yep, so that is it for me. I hope all of you really enjoyed presenting and doing the research for this. We really enjoyed a lot, and I just want to reiterate that we learned so much from all of you. So thank you very much for giving us your time as well.
Thank you, Labada. Congratulations, team UOPLites, Randula, and Team Metrics. Congratulations once again. The winners will be contacted by the Team OCTAVE to receive their prizes. So we've reached the end of our first ever OCTAVE Advanced Analytics Symposium. To conclude the session, I cordially invite Rajitha to give the vote of thanks. Dr. Rajitha Navaratne is the principal data scientist at OCTAVE and brings about 10 years of experience in applied machine learning and computer vision. He earned his PhD from Queensland University of Technology, Australia. Prior to joining OCTAVE, he worked as a research scientist at Walt Disney Imagineering Labs in USA. Over to you, Rajitha. Thank you all.
Thanks, Chamin. Thank you so much. First of all, congratulations for everyone who are the winners of first OCTAVE Student Symposium, and also wanted to congratulate for all the finalists as well. It was a tough task for the reviewers to finalize top 10 finalists. So congratulations for everyone. And as Lamana mentioned, I mean, it was very intense competition, and then we also learned a lot too. And also it was very interesting to see like how Sri Lankan students in universities, they follow these AI, machine learning and computer vision, deep learning, and these type of fields. As you're probably aware, like, you know, this field is rapidly going in a very positive way, even in Sri Lanka too. And there are a lot of opportunities are coming in this particular field as well. I just wanted to highlight even at OCTAVE, we also have different units within the OCTAVE too. Not only data science team, we have data engineering team, delivery team, we have visualization team, and also a platform engineering team. So it's a multidiscipline entire process of working on a proper data science or machine learning projects. So internships opportunities as well, and also a graduate program as well for all the new graduates. So we have planned very nice graduate program where you have the opportunity to go with data engineering team, data science domain, learn about platform engineering, learn about cloud engineering, and also visualization, how to deliver these things. So please go through our LinkedIn page too for the future events as well. And if you have any questions, please contact all the OCTAVE, especially the Sam, who's actually helping us at the backstage, doing huge amount of work for us to make sure that everything is going smoothly. So please free to contact OCTAVE, and we are all the team at OCTAVE, including all the data scientists, are happy to help you guys to improve your knowledge and to do a very good task in Sri Lanka. Actually, you are like the future and the gems of Sri Lanka. It's good to see these things are happening in a very positive manner. And I just wanted to thank judges for making their time to present today with their workload as well, and sharing their very good insights as well. And I believe we had a very good tough time to understand the winners. I also wanted to thank our moderator Chamori conducting such an event in a very smooth process to make sure that everything is going in a smooth way. And also wanted to thank Sam, who was organizing these things, helping us to have this session in a very successful as well. And finally, also I would like to thank the finalists and also making their presentations today. And also wanted to congratulations for all the winners again. Good job for everyone actually. And just finally, thank you for attending this webinar, and I hope you learned something new today, and we hope to see you again in our next events as well. Please follow our LinkedIn page, and so there will be a lot of events we will do, and all this information will be there on our LinkedIn.